This conference will now be recorded.
Hello everyone, welcome to our day 28 in our GSP Cloud Architect training, where yesterday we stopped at how to load CSV file, a CSV format file into an existing table using BQ utility and also using the console. So the append to table was a trick there, and we also saw how we can handle errors. That was a very manual way of doing it. There are some sophisticated ways where you are going to use some ETL tools, all those things. If there's any errors in the file uh, format, you change it, all those things. But if you were to directly load it with that option, what are the stuffs you can do is what I wanted to highlight there. So the max bad records was an important parameter. I had also seen that in the exam, and it's not because I see it, you will also get it. But since I saw it, at least I thought, let me highlight that flag so that you know there could be questions related to that. Either setting to 0 or setting to a non-zero value. What is the impact of it? You should be aware of that. So today we will see the remaining file formats which BigQuery supports. ORC, Parquet, Avro, JSON, and we'll come to a conclusion which format is the best one, which one you should avoid. There are various reasons why Google has provided different options based on the requirement, based on the use case. You can use either one of them. But if it comes to performance, which one is going to be the best one? We will see it. Okay. So yesterday we have seen CSV already. So I'm not going to again load a CSV file. We'll load the remaining stuffs all from our local system. So you should be able to see it in the Google Drive where the stuffs have been uploaded already. So let me open JSON file first. Let me open a JSON file, US states. So CSV over JSON. Let's open JSON. And this looks like a JSON, but it's not really a JSON. Actually, the actual name for this file format is called as JSON new line delimited. So if you see, one row would be mentioned in one line, one row. So you cannot, and if you just copy this entire stuff and go to a website like JSON validator, it's going to throw us an error. It's not a valid JSON because it's a JSON new line delimited. So if I just put here, it's a online website which shows whether you can validate it or not. So if I say, it says it's invalid. It's not a true JSON, because JSON, if you see, you should have a comma after every child node. You should have a comma, so it does not have it. So that's the reason it is throwing an error. So if I just make it something like, so if I try to put comma and see whether it is, so comma, and now it is a valid JSON. So you have to put square bracket. It should be kind of a list. Then you should also have a comma delimited. Only then it's going to be a valid JSON. So this one is not a JSON, to be very frank. It is called as JSON new line delimited. So there are a few utilities which helps you to convert a JSON into a JSON new line delimited format. Python modules are there, lots of modules are there, you can use them. So let's try to load this. The reason why I highlight this very specifically is I have spent time on this itself when I was trying to load a JSON file. Then later realized that it is not a JSON, but it is a JSON new line delimited format. So somebody says, I already have a JSON, can I directly load it? No, you have to do some formatting. Make sure you bring it to the screen. Somebody is unmuted. Okay, so you have to make sure it is in a new line delimited format. Very, very important. So there are 50 sets, so 50 rows are there in this JSON. Let me try to load it. Let me try to load it. So go to my BigQuery. I'll just pin it because we are going to do a number of times BigQuery. So I'm going to pin it, go to my BigQuery, and I'll use the the GA version of the user interface. So we already have a data set which is in Singapore, and we have one table which we created yesterday. Today we will create one more table called as United States, the states in US. So if I try to click on create table, again this is going to be from a local system, so I'm going to upload it. So these are the file formats which we are exploring. So the one which we are going to explore now is JSON new line delimited format. So let me browse it, go to my US states. It's going to find out that format is JSON new line and new line delimited. So I'll call it as US states. And a small observation, folks, with the naming convention, what I have seen is if you give a name to your BigQuery table, which is having under hyphen, there are some issues, undocumented issues, which comes basically. So prefer to always do use a underscore. If you have to separate two words, something like US state, something like that, make sure either you don't put any space, which may not be little readable. So if you want to make it readable names, please always prefer to use underscore. So I'll try to put this in the implementation cheat sheet. um, spend many times spending hours actually to fix that kind of errors. Some few things are never documented actually, so only when you do the implementation you will see those things. So let me just add that in the implementation documentation cheat sheet. May not be asked in the exam, but it's going to be something, an important one when you're doing an implementation. Avoid hyphen uh, in for BigQuery. Does it allow, first of all? It allows. BigQuery, what is that? BigQuery tables or BigQuery table name. Instead, use use underscore. So let's create this. I can just highlight this part one more time when I create a data set. So data set, when you create, right, it does not even allow you. They have done that fix in the data set level, but at a table level, they have not done that at least. So I can show you that one more time once we finish this part of the demo. So that's the name of the table. Now here, you can give auto schema. So, or if you want, you can detect, you can give name and post underscore abbreviation. So two fields only are going to be there. Both are string. If you want, you can give as usual how we gave yesterday, or just mention it as this, detect the schema automatically, then it's going to do the remaining steps. Now if you go to the advanced part, the options which you going to get is going to be different, folks. Depending on the file formats, the options are going to vary. So if it's a CSV file, what are the how do you delimit it? Then the header to be skipped, all those things are going to come. But if it's a JSON file, anyway, header is not going to be there, so that field is not going to be there. So but maximum bad records, should you append it or write it, all those options are going to be there. And encryption by default is going to be Google managed encryption key. So let's just click on create, see if it gets created. All right, the table gets created, and one of the highlight of this is we did not even mention the schema, but it took the schema from the JSON format itself. Looking into the details, it should show 50 rows. Perfect. Uh, Today we created it. This is something which I wanted to highlight. Table got created today at 6:11 IST time. So the table is going to expire 4 days from today. 4 days from today. So yesterday's bucket, yesterday's table which you created it yesterday. So it's going to get expired from that day of creation. So it's not that every table in the data set is going to get deleted after 4 days. From the time of creation, 4 days, it's going to be deleted or expired, to be frank. So it's going to expire on 29th of April. 29th of April. And you can look into the preview. It looks the same stuff. Because it is in a tabular form, you can query the same style how you used to query it. Sorry. Extend this. So sorry, folks. Okay. So since it's in a tabular form, you can go ahead and query it the normal style. So even though it was in a JSON format, you loaded. Now it's in a tabular form in BigQuery. You can go look into the stuffs. Like you can put various columns. Like say for example, get me all the names, standard queries which you would have done. Get me all the US names where the name is like ending with or starting with something like, you can put any like statements like it always starts with is there any state which starts with C? Yeah, C. So I'll put it like, okay, starting with C. So, and if you want to format, make it a little better, you can format it also. So now if I do, it's going to show only states which is starting with C. I can use all my skills of SQL here to get it. So this is how loading a JSON file format works basically. Any questions on this, folks? The JSON file format which we loaded, you just need to make sure it is new line delimited. If you make sure that you have addressed all the stuffs with your BigQuery loading JSON file format would be solved. If it is not, if it is like this kind of a format you try to load it, you will have all sorts of problems because it's not new line delimited. Remember that. Okay, so now let's go to the next file format. We'll try to load. Let me see what is the file format I have. I'll try to first I'll open one CSV file, folks. So CSV, JSON. Let me load the other file format. I'll go with Parquet. This is how the Parquet file looks if you try to open it in a Notepad++ kind of an editor or any normal editors. If you open, it's going to look like this. So first of all, what's your thoughts on this file format, folks? CSV, JSON, Parquet. Any thoughts on this file format? Any thoughts? Nothing specific to GCP. If you see something of this kind of a content, what is this kind of content usually called? Normal in computer terminology, they call this kind of file formats as something. What is this kind of file formats? Any thoughts, folks? Binary file formats. That's it. Binary. It's basically binary file formats. So whenever it is binary, what is the advantage, folks? What is the advantage you get with the binary file formats? This is human readable. This is binary file formats. So the advantage which you get, you may not get it, but the computers get the advantage. So individuals like humans, yes, fastness is going to be there. So humans can read human readable text. It's easy. But when it goes to the computer, the zeros and ones, the one which we learned in our school days, is going to be applied here. So this is more machine friendly. CSV and JSON are more human friendly. At the end, we want it to be machine friendly so that the fastness is going to be there. So faster processing. Yes, folks, so you are going to get it faster. So processing wise, if you slightly compare it with JSON and CSV, Parquet file is going to be faster is the key indication by just looking at our basic computer concept itself, because it's a binary format. So you cannot see anything there. So Now let me try to load this. So load it from my local system, user data parquet. So it is smart enough. It finds out that it's a file format of this. So I'm going to call this as user data parquet file. Now, what else do you see in the user interface, folks? I could have done this very easily in the command line. There was a reason why I did it in the UI. So what do you see compared to the couple of times we loaded the data? Now I finished it. Any new change which you see in the user interface, folks, compared to our CSV and JSON file format? What is that which you see as a nice feature which comes with Parquet files? Schema, folks. You don't need to mention the schema. You don't need to mention the schema. Now, if I just for a minute change it to CSV, you see this option coming up. You have to explicitly mention the schema, or you have to go with auto detect. But when I use file formats like Parquet, you don't need to mention anything because the file which I showed you is already going to have the the schema embedded. So you don't need to do that. So this is going to be little easier when you are loading the data. When you're sharing the data with somebody, maybe putting it in a Parquet file is going to be a better choice because they don't need to know the schema details, mention those details manually. So just they load the data, it comes up. It comes up. So under advanced options, you may have very little features which you are going to have. You will never get bad records because the format is already mentioned everything. So the chances of having that errors is going to be very less, very less. So you see an advancement or enhancement which we have done from moving from one file format to other. Now let's click on create, and this format I just got it from a GitHub page. You can just search for samples Parquet files, you'll get it. Or if you want also, you can generate. There are lots of tools to generate it. Next Saturday we will see one more tool called as data flow, which can also generate this. So the data is created. It's not the same data, folks. It is some other data which has some schema, some registration form, where it has some details about credit card, country, date of birth, blah blah blah. And you can look into the details. It has some 1,000 rows, around 140 kilobytes of data. If you're interested to do a preview, you can preview it. I'm not going to query it. It's the same concept. So it's the same concept. Uh, uh, this is what you get it. Now we have two more file formats, ORC and Avro. Let's look into that. So as usual, let me go to my Notepad++, ORC. Again, a binary format. So you would expect the same stuffs. It's a binary, truly a binary format. Let's just see how we can load it. So create a table, upload it from my local system, ORC. It finds that format and immediately the same stuff. You also don't need to mention the schema for your ORC files. So I'll call this as demo, or I'll just call it as user data. ORC. Same limited set of advanced options. Click on create. Table got created. If you look into the ORC, and once it is in BigQuery, nothing is going to matter. So at the end, it's going to like how you are going to load it, basically what file format. That's the only thing. Once it is in BigQuery, it's always going to be in rows and columns, basically nothing fancy there. So it has around, it's only having 2 columns. So looking into the metadata information, it has only 2 columns and some 21K rows. Basically, interested in looking into the preview, you can look into it. Some data. So basically, this is how it looks like. Now the last file format, let's load it. And there's a reason why I'm doing this. So this is going to be a manual task. So I could have just told you which is the best one, but I just wanted to give you a small information like which is going to be the best one. The last one is Avro. So this one also, you can read some text here and there, but this is also going to be considered as your binary file formats only. So meaning now you would have got an idea. So if it's a binary file format, there's a high chance that the schema is already embedded in the source. This is the source. The schema is going to be embedded here. So let me try to load it. One last file format. We should be all good, and we'll find out a conclusion. Which one is the best one? Avro. Then I'll call this as user underscore data. To be very frank, the Parquet file and the Avro file, which we are going to load now, the content is same, folks. 1000 rows, same stuff, but shared in two different file formats, basically. So I'll show you that maybe once I finish this part. So basically the same setting, source file defines the schema. So you don't need to explicitly define it. Click on create. The file is created, the table is created. Always make sure you spend good amount of time on the schema details and the preview, because these are going to give you a better idea what needs to be, what fields to be used or what columns to be used. And these activities are totally free, so you will not be charged. So leverage the schema details, all those things. So it's the same set, folks. It's the same stuff which you saw with your Parquet files, same stuffs. In Avro also same stuff, same 1000 rows. So no difference there actually. Now 5 different file formats we saw. Now let's have a small conclusion. And we did not do that actually basically to see the time, how quickly it loaded, because we did not have the same day content. So it was not an apple to apple comparison. So that's the reason I did not do that. Maybe as an activity, if you want to do, have one small set, make sure you export it into all the different file formats and give a try, and you'll come to a conclusion yourself, indicating that Avro file formats are going to be the best file formats when you want to load it faster. That too compressed version of it is going to be the fastest one which gets loaded in BigQuery. The whole reason why I did this demo was to show you that always prefer to use Avro. Now, if it's a person who has worked on data warehouse, he knows how to query, all those things are fine. But he may not be aware that in BigQuery specifically, Avro is going to be a better file format, that to compressed version. So you as cloud architect, when you're designing an design specification, make sure if there's a requirement that you have to export it from some source to BigQuery, make sure it is in an Avro file format. That is very, very important. So the slowest one is JSON new line delimited, that to compressed. That's going to be the slowest one. And the middle guy is always going to be our favorite CSV file. So it's going to be our CSV file. So only based on this only I wanted to share you that information, folks. Any questions on this part, folks? Any questions on this file formats?
Mahesh, it's only like while first time when we are loading the data only it takes some time, right? But it's not like once we load the data when we are doing the preview or selecting the data from the tables, that time it won't take time, right?
Beautiful question. So when you're doing preview, all those things, you are doing it on the table itself, on the
Exactly.
content which is already stored in the BigQuery. So you're querying actually the BigQuery data set, the table. So it's going to have no impact. It's the same experience. It's only the loading. Now we were just loading 1000 rows, so that's the reason you would not have even seen a great difference there. But if it's something like millions of rows, uh, millions of rows with CSV format, you will see slowness. But if it's millions of rows with Avro file format to compress, you'll see it loaded faster. Totally
So
true. It's going to be only during the initial stage of loading.
and also the pricing, while for example, I have a JSON format and CSV format, and I have 1 TB of data, for example, and it may take maybe 1 hour, but Avro takes like 30 minutes. But it doesn't mean that Google will charge me more money because I use the old format like CSV and JSON format, right? Because
Zero. Free
yeah,
load.
exactly,
It is
exactly.
free. It's free.
Okay,
So the
okay.
loading, bulk loading is free, so does not matter. It is only that uh, cost is
Takes
not
time. That's all. Yeah.
it's zero. It's only taking time. So people will
Okay.
lose patience when they are doing this. That's the only thing.
Yeah. Thank you. Thank you.
Yeah. So that's something which I wanted to highlight, folks. So that's this demo, loading it, and we got a conclusion. So, and we will not use other file formats, at least in our demonstration purpose. The following demos, we'll go back to CSV itself. Now, what we'll do is all the tables which you saw so far was uploaded from a local file system. Now, there's going to be a limit how much you can upload from your local file system. 10 MB is the maximum which you can upload, meaning if I close all these things. So if I click on in the user interface, you can look into the documentation. If I click on upload, this browse option, right, can take maximum 10 MB file only. If you upload try to more than that, it's going to say it is not allowed. So they have put a limit in the user interface. This is only for quick loading. So if you were to load GBs of data, you should not even do this option. Better use it in the command line option. That's going to be the best option. Or what you need to do is you have to upload it to a staging environment. Use that staging environment and do it. What could be the possible staging environment which you can use, folks? You have to stage the data somewhere, then and it should be definitely in GCP, a product in GCP, then load it. What could be the best staging environment which you can use? Bring that data to cloud. Yes, Anil Kumar. So buckets, use Google Cloud Storage as your staging bucket, then load it. So that's what we are going to do now. So what we will do is load the CSV data, same data only, load it into Google Cloud Storage bucket, and then try to see how we can work with that. Okay. So for that, it's been a while we did not create our buckets. So I'm just going to quickly create a bucket purposely in the command line only, folks. Now, it's very, very important. Now, a question to you people. I need to stage it. You people mentioned storage bucket is going to be good. Now, should I go with a multi-region bucket or a region bucket? Now it is called a standard. So which one should I go with, folks? I want to stage it, and why? And why? And based on this BigQuery demo which we are doing, in which specific region I have to create a bucket? So a couple of answers from Anil Kumar and Kumar are good answers. Any specific region I have to choose, or specific multi-region which I have to choose for this demonstration in our context? Where should I create a bucket? We know buckets are multi-regional and regional and also dual regional. Which option is going to be a best one? This bucket could be used for multiple times. Yes, Anil B. So it has to be in Singapore basically, because my location is going to be, my BigQuery data set is going to be in Singapore. Now, depending on whether you are going to load it offload from your Google Cloud Storage into BigQuery, As a native table, it is preferred your storage bucket is a regional one because you're doing data processing, folks. This data which you're going to upload, CSV files, all those things, nobody wants to access it with the lowest latency, but it should be close to the processing unit. So always prefer to use regional buckets or standard, so-called as standard one, but it has to be in a specific region. Use that. And in this context, as Anil B mentioned, it has to be in Singapore region because my data set is in Singapore region. So this is where important stuff comes. Many times data engineers are going to make a mistake. You as a cloud architect should definitely pitch in and mention this in the design document. So always keep your storage bucket close to your data processing component. In this case, it's going to be our BigQuery. So let's create a bucket quickly. So GSUtil make bucket minus C regional. The class is going to be regional minus L. The location is going to be and the name of the bucket. Let's use GUID generator. Trying to follow as much as the best practice. Staging. That's it. Bucket created. Done. Now, what I'm going to do is I'm going to use the same data yesterday which we loaded, the first data in BigQuery, the 9 rows. The same thing is what I'm going to do it, folks, into the bucket and show you the difference which is going to happen. So now I don't have that in my Cloud Shell. I'm going to upload it from my local system. Uploaded. GSUtil copy BigQuery console, and the bucket name is this one. Done. File is copied. Now what we'll do is we'll try to load the table from this bucket. So not from our local machine, it is from our bucket. So from the bucket means you can have whatever the size is. BigQuery is also serverless. Google Cloud Storage is also serverless. Both can take petabytes of information. You can have huge amount of data there and you can easily load it. So ours is only few KBs or bytes. That's okay. So the concept gets clear basically. So first time we are going to use not upload option. We are going to use storage bucket. We are going to use storage bucket. So the moment I use this, right? If I use upload, you see the table type is always native, folks, because it is coming from your local machine. So there's no environment where it is already there in GCP. So it has to be definitely stored in the native format, the storage component which you get in BigQuery. But if you are uploading it from the source is from a Google Cloud Storage bucket, you get two flavors, folks. Two flavors. One is native, meaning the data gets copied from your Google Cloud Storage bucket to your BigQuery. So it's an egress cost for your storage bucket and an incoming request to your BigQuery. So because we kept it in the same region, we would have saved the egress cost. Okay, no networking is there, but if you are reading it, it's going to be an egress cost. So, but we have smartly made it in the same region, so it's going to be nullified. Now, if you make it as external table, what's going to happen is the data is not even copied. This is the federated option which we saw yesterday in the slide. So we are going to see both the options. So first, let me go with the native option. So browse, go to our bucket. So you will see the buckets here and select it. So a green tick indicates. Now this bucket, you may ask, because you are in the same project, you are going to get it very nicely. If I have the data in some other bucket, some other projects bucket, how can I do it? You can just basically do a search kind of a stuff. You can get it also. So I can also put some public storage buckets here also. So it's just a matter of putting the search and you should be able to get it. You can just mention the complete name, you'll get it. So since I'm in the project, I see my projects bucket details. So BigQuery, done. I have two options. I'm going to use native one more time. So I'll call this as employees underscore native underscore GCS, just to indicate that you need to have this kind of it's a native table basically, because we are going to do a external table in the next demo. So now I can put the schema. So make sure I'll put it quickly. First name, department ID, which is integer, then joining date, which is date, the most troublemaking column or data type. I just keep this, maybe we may use it again, just handy to save some time. So that's it, the same stuff which you did yesterday. So you may skip one row because it has a row which has the header, so I need to fix that, and there's no error in, at least in this data set. Otherwise I can mention the maximum number of records, which is going to be bad records. That's it. So what we did, the only difference was we selected the source not from a local system but from our storage bucket. That was the only change, which gave us an option to have native table and also an external table option. So we are going with native for now. In the next demo, we'll do a external table. Click on create. Awesome. The job got created. The table is also created. Job was successful. Table got created. Looking into the details, same 9 rows. Preview, all are fine. So I don't see any difference. But the big advantage of this approach is, as I mentioned, more than 10 MB of data, you can put it in Google Cloud Storage, read it, make it as a native table, and you can do it. No difference between employees table and employee underscore native GS table. Both are same stuff. Both are native tables. Both are having the same data set. No difference. Now we'll do the next part of the demo, which is going to be the most interesting part of it. So external tables, meaning the table resides in, basically in Google Cloud Storage bucket only. So for that, let me click on create Google Cloud Storage, do the same thing, browse, CSV. Now you will see some changes in the screen, folks. The moment I make it as external, I'm going to make it as external. Some changes happens. Basically, if you see, if it's native table, you get some features like, which we have not even explored. We'll explore it today itself. Partitioning and clustering, you get those options. But the moment I make it as external, those features don't exist for an external table for various reasons, because the source is somewhere, not in BigQuery. So you cannot do partitioning and clustering. What is that? We'll explore it later, but that feature is not available for an external table because the source is going to be in there only. You're not allowing it to create a copy into Google Cloud Storage bucket, into Google Cloud BigQuery storage option. So it's going to reside in its main in its source itself, which is in this case Google Cloud Storage. So you get something called as source data partitioning. Rather than having partitioning at your table level, you get a different partitioning at a source level. So you can add the schema. Let me just add the schema quickly. So under advanced option, you can mention the same thing. So I want to skip rows. Now, the only difference which you saw when you were making it as native to external was, if it's native, you get partitioning. So if you make it as external, you don't get that. You get something called a source data partitioning. At the source level itself, you do some partitioning. So divide your content there itself is what it's basically saying. So I have to give a name, employees underscore external GCS, folks. This is the one. So let me click on create. All right, the table is created successfully. Let me click on this external table. Now, what's your thoughts on this, folks? Now, first of all, what do you see quickly when I click on this table? Schema. Any change in the schema? No. Clicking on the details, do I see any changes, folks? Do I see any changes? So let me try to, yeah. Any changes do you see, folks, with this external table? Source URL, it indicates where it took from. Beautiful. Kumar, that's good. Sridevi mentioned the size. Size is important thing. Total table size is 0. The number of rows are 0. It gives you a thought that maybe the data itself is not loaded. So good. So you see this external source. That's good. Size is 0. That's good. What else you see as an observation, folks, with this external table? Any other observation? Absolutely fine, Sridevi. That's good. No preview, folks. There's no preview option itself. Now this very clearly indicates only if you do it as a native table, you get some benefits. Because it's in Google Cloud Store, Google's BigQuery's native storage format, it can do some extra stuffs and give you some additional information without you querying it. But if you keep it in some other external source like Google Cloud Storage, data, Google Drive, or Big Table, you will not get those benefits. So even to do a preview, you have to query it. And it is very clear the number of rows which was showing was based on the preview option only. So something internally was happening to get us the number of rows, the table size. Now the table size is always going to be 0 because it is not stored in your Google BigQuery native form. So 0 storage is always going to be 0, which very clearly indicates it's an external table. So you will not have a preview option. So you have to make sure you you query it and only get it. So if I just query it, so if I put first name, department ID, it will always show even in your dry run. It's going to always show 0 bytes only, 0 bytes only. So only when you run it, it's going to show you the actual result because it cannot do all the stuffs. Nice feature which Google had provided. It was only on your native table, not on your external table. So now only after running it, it may show me the details, how long it took, how much bytes was processed. Now for me, the storage cost is not going to be there with respect to BigQuery. The storage cost is going to be the same as the storage cost of my Google Cloud Storage bucket. How much you have stored. But in BigQuery, only your query cost is going to be there. So what I mean is, if I just go to my pricing calculator, so if I search for BigQuery, so the one which you are going to do now, you should be putting like this: 0 storage cost, because nothing is stored in BigQuery, but you're going to have query cost, maybe like 1 GB or whatever it is. This is how you have to do it. And you should add one more component, which is Google Cloud Storage. There you have to put your storage cost. What is the volume of data which you have? So please make sure you are going to use that way. There's one question. So will there be any difference if we use select star or specific field? So the amount of data which you're going to read is going to be different here. So if I add basically the joining date also, the amount of data which is going to be processed, which you are going to read from your big Google Cloud Storage, is going to be more. So which is going to be add to your egress cost, Kumar. So it's not going to be 183. It's going to be more than, is it the same? So it does not make any difference. 1 minute. Is it reading the full thing? 1 minute. Never tried this part. Let me just see it. If it's only one columns, let me just see it once. It's not making, actually it is reading the entire table, folks. Entire content in your Google Cloud storage. So it is not making any difference, Kumar. It is not making a difference. So what Kumar is asking is, let me just explain it. So even if I put select star, and run it, it's just a querying layer which we have put. For example, if I just go to my storage bucket, back to my storage bucket, gsutil ls. So gsutil, there is a command where you can see the size of your bucket, folks. Size of your bucket called as du minus sh. So if I use this, it's going to show me the content, basically the size of this stuff. So if you remove the header, yesterday we had seen, if you remove the header, the total size in the storage bucket is 215 bytes. That's what it indicates. If you remove the header, all those things, if you remove it and do it, if I just go show you this one, if you go to that level details, you can see it. This is the total size of the file. Same thing is what it shows in storage bucket also. Now if I remove this row, which is going to be skipped anyway, now look into the size of it. It's going to be 183 bytes. This is the complete data, this thing. So it's going to load the complete file, and on top of that, it's going to show you a querying layer. So gives you that option of querying. Now you are making your Google Cloud storage smarter, but as Kumar mentioned, it's going to query the entire data. So there's no difference between, if it is an external table, you will not see any difference putting select star or basically putting a select specific value. It's going to read the entire file basically. But you can make some enhancements, which I'm going to show in the next demo, where we are going to use some wildcard. By doing that, you can enhance to some extent. How? I'll show you that in a minute. So what we have literally done is basically the content which you see here. This is what I can do maximum in a Google Cloud Storage bucket. But by adding it as an external source to my BigQuery, I can put all my querying logic, folks. So where first name starts with people like it starts with A. Do we have people with A? Yeah. So A percentage, that's a wildcard search, how you do it in normal SQL. So Andrew, Anna, Anthony, these are the people. Now you have made your storage bucket smarter by using this. But for every query, it's going to show always, it's basically, it reads the complete data, does a querying logic on that, filters out and shows the result. Okay. So I hope this part is clear. And to add to Kumar's point, I'm just going to put that in the chat, what Kumar mentioned in it. So this is what Kumar mentioned. So will there be any difference if we use select star or select specific fields? At least in external table, no difference. No difference. That's what you saw. So if I put something like only first name, it's going to be again, the amount of bytes of data which you're going to process is going to remain the same. It's going to be the same. Okay. So I hope this part is clear, folks. I hope this part is clear with respect to external table. External table, how do you load it? Now there's a demo which is not there in the list. We'll try to do that. What is that? Now, there are how many rows which you get? So if I just put select first name itself, if I query it, because there's no preview option and all, I have to query it explicitly. So if I query it, there are 9 rows. Now assume a 10th employee came. How will you make sure? And the source is a Google Cloud Storage bucket. Now, how do you add a new line into this file, folks? How do you add a new line into this BigQuery underscore console.csv? I have to add the 10th entry. How will you do it, folks? Can I go open it in an editor and do it, or do something else? What are the options which I get? Like, can I do gsutil edit the file name, something like that, or any other options? Please let me know. Hope the question is clear, folks. 9 employees are there. A 10th employee joined. So I just need to add this. Yeah.
One thing I'm not sure it is correct. The copy the file in home directory of your cloud shell. Edit using VI editor and then again copy back to the Google Cloud.
Okay. That's the only option existing, Mangesh. So that's the only option. So basically, this falls back to the concept which we learned. Google Cloud Storage. The objects are immutable, folks. You cannot change the content. So you cannot go do edit in a storage bucket. You will not have an option because it's immutable. Now, if you want to have a new content, like what Mangesh mentioned, so I already have the content. So I'm going to use some nano editor. So this is my content. Now what I'm going to add is, I'm going to add another row, new employee. Department is 1 and today's date is 2021 April 25th. So this is how I do it. So do a change in my local system, then upload it back. So if I see, is there a command where I did? Yeah, I copy it to my storage bucket. Done. Now if I do cat, I should see that new employee row. Now that's it. I have not even touched my BigQuery stuff. Without even touching my BigQuery, I've just changed my source. Now you'll really appreciate the value of a external table. You just do the changes. Now you just come and query it one more time. You will see 10 rows. Let's just see whether it's going to reflect or not. You see that, folks? Now this is the main advantage of people going with external table. But there could have been a better option which we could have used. This was a tedious option, right? Because it is only 10 rows, you can go open it in an editor and do it. But what if it's having millions of rows? Nobody would prefer to do this kind of an editing. So this is where you will use a feature called as wildcard. So what we will do is, when we create a storage bucket, we'll make sure we will create a pattern, and we will always upload the data in that pattern. That's what we are going to do. So the next demo which is going to be done is again external table, but we will leverage the pattern. We will leverage wildcard pattern. So for that, what I will do is basically have something like this. So let me get some couple of data sets. So I'm going to use basically, I'll use this, folks. Cloud Shell, yeah, this one. I'll use this data. Okay, we'll create a new table where we are going to use the concept of wildcard. How? Let me just show you that. So I'll copy this, but I'll copy this to a specific folder. I'll create a folder in Google Cloud Storage. So I'll call it as wildcard or batch 6. I'll call it as batch 6. Batch 6. So inside that folder, inside the bucket, I create a folder and I copy my cloud shell.csv. So putting slash towards the end is very, very important, folks. Otherwise, the file which you upload will be treated as batch 6. That's it. So, but if I put slash, what it's going to do, it's automatically going to create a folder, and inside that folder, my file is going to be copied. So copied. Now, if I do list the content in this bucket, you should see a folder structure. Okay, it does not show recursively. If you want to do recursively, put -r, it shows recursively the stuffs. So still now we are learning gsutil commands. So put this, it's going to show this one. Now what I will do is I have loaded only one file content. So one file content. So if I just show you what is there in this, same style only, but I made some kind of a provisioning to put that everything is going to be inside into a bucket. Now I'll create one more external bucket and see how it's going to work. So create from this bucket. So now I'm going to select this and this one. It's not selecting. Okay. Now, if I just do like this, right, folks, if I just do like this, what's going to happen is it's going to always refer this file. Instead of this, I'm going to make a pattern, something like this. Any file inside this folder called as batch6, BigQuery underscore anything, it can be ending with .csv. If it is of this format, I can query it. Hope this part is clear. So I'm just trying to make sure not read from a specific file, but a series of files in a specific folder. Now tomorrow, if a new employee log joins, I don't need to go and edit the file. I'll create one entry in a CSV format with the name BigQuery something. Then you should be able to upload it. It's going to automatically reflect. The metadata should be same. So basically, in the sense, not metadata, the schema should be same. Provided the schema is going to be same, you should be able to easily load it. So the job becomes very simple. So you don't need to touch anything in BigQuery. You don't need to touch anything in your Google Cloud Storage bucket. You always follow that format. First name, comma, department ID, comma, date. Assuming everything is going to be put in the right format, you should not have any trouble itself. So any trouble, let's make it as external table, employees wildcard, schema, sorry, I'll just copy the schema, and I don't need to skip anything, folks, because there's no header, so I don't need to skip the header here. So I can just leave it as the default setting. So now when I create it, it's going to create 3 rows, basically 3 rows. It's not going to have preview. The table size is going to be 0. The number of rows is going to be 0 because it's an external table. So wildcard, no preview. So shows everything as 0. But when you query it, so let me query it. First name, 60 bytes of data. That's it. Now what I will do is a 4th employee needs to be added. So how will I do it? Basically, if I go back to this thing, I'll create a file, BigQuery underscore batch 6.csv. So format is proper. So I'll call this as wildcard employee. Department is 2. Date of joining is 2021 April 20 today. That's it, folks. So one entry I added it. Now I just simply copy it. Should be all good. So let me just do this. gsutil cp, and please make sure you copy it into that right folder. Otherwise, it's not going to pick it up. So make sure you copy it. Done. File is copied. Now, if I run this query, it should show me that new employee information also, the wildcard. That was the name of the person which we gave. It shows that. Now I see it does not make any difference. It is loading the complete data. So even if I put select star, so going back to Kumar's question, even with the wildcard, you don't do it. I thought it's going to do some changes. No, it is loading both the two. It's basically going to do select. It's going to do star. So it's going to get all the table, all the files. On top of those files, it's going to basically apply this logic, the querying logic, and get it. Why I'm saying it is all taking everything is, if you just go inside this bucket. So if I just put du minus, to know the size of this content, du minus sh 90 bytes. So it has two files added together. It's going to be 90 bytes. So no difference, actually, no difference. It shows everything. So from where is it picking the old data? So basically it has everything here, Kumar. So in this folder, right? So if I put ls minus s inside this folder, I have two files. One is BigQuery underscore cloud shell. The other one is the one which we uploaded. So old data, or the 3 rows are coming from here. 1 row is coming from this one. Basically, it is joining all these files and running a query on top of it. Hope that is clear. And it also shows how much is the total bytes. Is that clear, Kumar? Yeah, I thought it takes only one. No, it's not. And one more thing, folks, I just use this du minus h only for showing you the concept. Okay, please don't use this command heavily, because the cost is going to increase, because this is going to be a class A operation in your storage bucket. It's going to little incur cost more, but you can use smart commands like ls minus l, which may not cost you a lot. It also shows you the bytes. So it's recommended not to use this heavily. In time, you can use it, but don't use this heavily, du minus h. Okay. So now we saw basically how your wildcard stuffs works, external table works, all those things. Now for a minute, what I'm going to do is, we kept everything in the same region. Things work like so beautifully. For a minute, I'm going to create a table, a storage bucket in Mumbai, and I'll show you what is going to happen. Okay, so quickly create a bucket -c regional -l Mumbai. Mumbai is going to be this one. So if I just go use my GUID online, generate, copy it. I'll call it as MUM Mumbai. Done. The file is copied. Now what I'm going to do is gsutil. I'll copy only one file, folks. I'll copy Cloud Shell. So gsutil cp Done. Now what I'm going to do basically is data set is in Singapore, or the actual source is in Mumbai. What is going to happen when I do something like this is what I wanted to show you. So create a table, storage bucket. Now Mumbai, yeah, this one. Select that file. Now let me make it as external table, folks. Make it as external table. Give employee Mumbai. There's no okay, you need to give the schema. Let me just give the schema. Anyway, no headers. I'm just going to leave it. Now if I do it, you will see an error message, folks. Let's see. Not now. Okay, not now. When you query it, you'll come to know that error message. Now the table is created successfully. So source is in a different region. The processing unit is going to be in a different region. Let's see what is going to happen. So employee is there. Query this table. So if I look in the details, it shows everything. It is from a different region. Now if I query it, even put select star, or let's not put that. First name. The syntax is correct, but there is an error which is already showing up. Let me go ahead and still run it and see. What does this mention, folks? It says I cannot read it from Mumbai. So if my processing unit is in Singapore, I cannot read it. So this is an important stuff which you need to remember. So that's the reason you should never create resources in two different regions. So data set is in one region and your source is in another region, you'll have issues like this. You'll have issues like this, and if it's an external table. The same thing if you try to read it from a storage bucket, but it is going to be native, it's going to show basically as show it as the same message, but while doing creation itself. So it does not mean BigQuery is not multi-regional. It is multi-regional. You can do that. It depends on what is the data set you have used. The data set which you have used is a regional one, and you cannot do something, expect more out of it. Now, if you see here, it is a regional data set. If you want this kind of capabilities, when you create your data set, when you create your data set, make sure your data set itself is multi-regional, folks. Then you can expect all those kinds of stuffs. Okay, either you can use US or you can use European Union. These are two multi-regional data sets which you have. Then if you have a data set, it is in US. Then if you put something in any regions, a bucket in any of the regions in US, you can easily read it. You can easily read it. Okay, so make sure it is very clear. Let me do one last demo and we'll take a break. So if I create a bucket, storage BigQuery table, same style, same style. Now, last time we did external bucket, it did not even throw an error. So only when you started querying, it threw an error. But when I make it as an external table, and this storage bucket is in some other region, and in BigQuery, if you try to do a native thing, I wanted to show you that when you make it as a native table, what actually happens is the data gets copied, literally gets copied. So can be seen by this process. So same thing, it's reading from Mumbai. If I make it as native, give a name, demo, have my schema. Now, if I click on create, right, it's going to throw me an error right here itself. Right here itself, it's showing that source and destination cannot be different. So cannot read and write in two different locations. So reading is from Mumbai, writing is into Singapore. It's not going to be allowed. So this is very important, and it very clearly shows when you make it as a native table, and if the source is from a storage bucket, it's going to copy basically. So hope this part is clear, folks. Many data engineers do this mistake. So if I just open this one, who knows, there could be a possible question on this. Better have an exposure on it. Cannot read and write from two different locations in BigQuery. In BigQuery, if the data set is a regional data set, is a regional one, you can do it as a small activity, make it as basically a multi-regional data set. Only two regional data sets, multi-regional data sets is possible. One is basically your US, the other one is just your European Union. Give a try, you will not get this error. So okay, so just wanted to highlight this part. Now let's take a 10 minutes break, folks. Once we come back, we will explore more stuffs, slightly complex stuffs once we come back. So we will talk about partitioning, which could be important from the exam perspective, basically. So we start with a small data set, slowly move to a larger data set. Okay, so take a 10 minutes break and come back.
This conference will now be recorded.
So far, what we saw was a very basic concepts of BigQuery, where you have a specific file format, you load it, and we explored that. Just before the break, we also saw how external table can be used. The pros and cons of external table, both we saw. So the positive thing or the good thing about external table is no data duplication. That's the biggest one. So it's going to stay there in your actual source. You are not duplicating it into BigQuery. The drawbacks are many. You should never expect the same response from an external table, because it's going to read it from an external source, right? The time it takes to process it, it's going to be definitely more. But if it's on a native table, it's going to be little faster, because everything is native, so it's going to be faster. So you'll get some cool features if you use a native if you use something called as native tables, like preview options are going to be there. Then you can get to know that what is that dry run, you can do all those things. You are going to get it, basically some cool features, but which you don't get that in your basically in your external table. And one important thing is with the external table, uh, one thing with the external table is, if I just go to my external table, query it, query for first name, and run it, it shows me the result. If I run it one more time, it's going to create that cache. That cache component is going to be still there. That's going to be there. So that's what here you see it very clearly. When it is doing the cache, right? When it's doing the cache, what you can do basically is you can look into the there it is creating a small copy for 24 hours. So the cache part remains the same irrespective whether it is an external table or an internal table, because it's going to create a copy basically. So if you run it multiple times for the same day, it's going to be always coming from a cache. So remember this part. And if you want to know the cache, the table details, you can always go to your query history, click on that specific query which you ran, and you will have this destination table, which is temporary table. So if you click on it, it's going to basically go to your cached content, which is going to be a native table, and it's only going to be for a day. Only going to be for a day. How that concept is clear, folks. So you compose a new query, hide it. Now what we will do is we'll learn some more advanced concepts like partitioning, clustering, all those things. So when to use that also, we'll try to see it. So for now, if I just go back, we are going to use this from the bottom, the fourth demo, explore partitioning. And partitioning usually comes when you're exploring it on a large data set. But I would like to start it with a small data set so that you understand the concept. So we are going to rely on the same employee table only. So let's try to learn it on the same employee table. So it's going to be a small data set. Once you understand the concept, we'll start exploring it on a bigger data set. Okay. So only because this is serverless, I would like to always do with a smaller data set. So that's going to be easy for learning. And also, even if you make a mistake, it's not going to be a costly mistake. The reason why I started with smaller data set is in the beginning, when I used to do training, I never used to do it on a smaller data set. And even if you see any demos by Googlers, they always try to show it on a large data set. That's the value of BigQuery. But when you are doing it right, because when Googlers do it, they would have done it, practiced it, they would have that expertise, they would have worked on BigQuery for a number of years, they know how to do it. And also, even if they make a mistake, it's at the end not going to incur them a huge cost because the company is going to pay for them. So but if you use a free trial account, so in one of my beginning days, I ran almost like 16 terabytes of data just to show, doing a demonstration that how it works. After I finished it, right, the demo, it was successful demo showing that it was able to query 16 terabytes of data in a very few minutes. Next command was basically to create a virtual machine. I was not able to create virtual machine because I exhausted my credits in one single this thing. Already had used good amount of stuff in my free trial account. This one incurred roughly around $70 to $80. So everything got exhausted. So we can make that costly mistake. So I don't want you to do. I did it, so I don't want you to do that. So that's the reason we start exploring with small data set. And if you are a person who works on data warehouse or databases very frequently, there is an option, slightly out of topic, there's an option called as BigQuery Sandbox, folks. So there's an option. So if I just go to BigQuery Sandbox, it's a very cool feature where you don't need to mention any credit card. So 2 years back itself it was created. Just a minute, sorry. Okay, so there's something called as BigQuery Sandbox environment. So you can use this option. All you need is a brand new Gmail ID, folks. So if you have a brand new Gmail ID, you should be able to basically use this forever. Nothing like your free trial, which is only for 90 days. So here in this BigQuery Sandbox environment, you're going to get every month 1 TB of querying and querying capacity. So after, if you exhaust it in one day itself, you have to wait till the end of the month so that it gets reloaded. So for people who want to explore more on BigQuery, this is going to be a good choice. And you can create n number of Gmails, so you can create n number of times even if you make a mistake. So prefer to use this one. Not even a single credit card information is going to be required. So leverage this, folks. Coming back, we'll explore partitioning on a smaller data set. So the data set looks like it is also there. So it is called as BigQuery partition. Now, if you just do a quick comparison between the first data set which you loaded and the second data and this data set and this data set has no difference, folks. The content is the same thing. Content 9 rows, same people, Isabel to Anthony to Anna, everybody is there. The only difference which I have done here is I have done some slight grouping, folks. People who joined on a specific date, I have tried to put them together. So here it is not in that order, it is randomly put, but in the BigQuery underscore partition.csv file, I have put an order grouped by their joining date. This is what I have done. And this is the same concept which you are going to use with your partitioning. What does partitioning do is basically, if you have huge amount of data, for example, let's take this scenario itself. It's an employee database. Now and assume this company is 50 years old company. So they are using, for the last 50 years, employees would have joined, they would have left. So good amount of records are going to be there from the beginning. If assume they have captured all those information, and recently they have migrated to BigQuery. Maybe like last 5 years they are using BigQuery. Now a new HR, head of staffing, the human resource HR joins. This person wants to know some statistics, how many people join, how many people leave, so that he can do some better strategies and all. So now if we ask for a report, get me the report um, of all the employees who joined in February 2020, only February 2020. Get me only the details. Only for that short 28 days, how many people joined? He wanted to know that. Now, if you have not done any kind of grouping mechanism, you're going to scan the complete 50 years of data to get this. You're definitely going to put a where clause. Definitely it's possible. You can put a where clause where the joining date is between February 1st to February 28th. You will get it. But the slowness, it has to first do a full scan, then put a filter, all those things. So if you can take an additional step called as partition it. So you partition, because every day you are going to load one information, an employee information means, why don't you partition it by date? If you partition it by date, what is going to happen is every month's data is going to be partitioned. It's going to be grouped a specific category. Now instead of querying the entire database, you only query that specific category. This way your performance improves. The amount of time you are going to spend to query is going to be less. The amount of data you are going to query is going to be less. That is the whole advantage of partitioning. So in literally this is going to be something like this. So when it gets stored in BigQuery, this is going to be one partition, this is going to be another partition, this is going to be another partition. So I'm going to have basically 3 partitions in my BigQuery. So how do I do that is what is a demo which we are going to see. So that's a basic stuff about partitioning, and this partitioning is a concept people who work on database, they use in day out. So every database will have this feature, and don't please try to compare the partitioning features which you get in Oracle, MySQL, all those things with BigQuery, because it's going to be totally different. I would say the partitioning demo is going to be the partitioning feature in the database is going to be more sophisticated compared to BigQuery. BigQuery has a limited capabilities only. I will set the expectation right in the beginning. So when it comes to database, you can partition any kind of data types. But when it comes to BigQuery, you can only partition date, uh, time, and integer. Only 3 data types can be partitioned. If you have a string, float, all those kinds of stuff, you cannot even partition it. So to do that, there is a different option there called as clustering. So it is limited features. Please don't try to compare it. Okay. So with that background, what we will do is we'll try to do a demonstration. By doing the demonstration, you will try to understand the partitioning features. Okay, so till here, any questions, folks, on just the explanation of how partitioning works in reality, how it's going to be useful? It's going to help us reduce the amount of data which you are going to query it. All right, now what we'll do is same data but slightly arranged in a different fashion, only for a self-learning purpose. So that to visualize how it's going to be there, I have put it in this order. Now what we will do is we'll load this data. So back to upload option itself. So I'll upload this one, BigQuery underscore partition. Now I'll give it as employee is underscore PBIT. What is this PBIT? I'll explain you in a minute. such a small short form which I use, not an official short acronym, but I use that. So what is that? I'll explain you in a minute. So now what I'm going to do is I'm going to basically for the first time use auto detect. For CSV file we never use, for JSON we used, but for a CSV file we never use. Let me use it now. Okay, so I'm going to automatically detect my schema. Even if you have 1 or 2 rows also, the BigQuery is very smart. It's going to detect the schema, meaning it's going to say the first row is basically a string, second is going to be integer, the third one is going to be date. It can do that very smartly. So that's what I'm going to do. Now, for the first time, we are going to use partitioning option. So when I click on this, I have 2 options. No partitioning, that is what you were doing all this time. Now there is one more option called as partition by ingestion time. So this is the acronym, folks. PBIT, partition by ingestion time. What do you mean by that? So there could be scenarios, at least not in our case, but there could be scenarios where the data which you are going to use in BigQuery does not have a date field itself, does not have an integer field itself, but you still want to partition it. And assume you load this data once in a day. So yesterday Kumar had an example, right? If I load every day once, what will I do? So in that kind of a use case, you want to still optimize your query performance and all, meaning you can use this option. Now you are ingesting, so it's going to use basically UTC time format. So if I use UTC time now, the time now is 2 a.m. So I'm going to mention this. So meaning if I ingest the data now, 2 p.m. is going to be the time it is going to take it as my ingestion time and partition it. Tomorrow at the same time, if I do it, it's going to partition it by tomorrow's time. So now if there's a data set where you're going to query per day kind of a content, this is going to be helpful. So you use partition by ingestion time only if your data set does not have a date field. You may say we have it. Why it is not showing? The reason is because you chose auto schema detect. So I wanted to highlight what is the drawback of it. So one advantage is the schema gets automatically created. But when you do auto detect, you cannot use partitioning on that table. So you have to use something like partition by ingestion time. And this is an important thing, folks. When you partition it, right, the whole reason why you partition it, you want to put a where clause on a specific partition. So if you don't check this box, what is going to happen is you can query the table without a where clause. But if I put this checkbox, partition filter required. Requiring a partition filter means user must include a where clause. A where clause is a must. All this time we never put a where clause. Couple of times where we put a simple where clause. But here you have to put a where clause, and you can put n number of or operations or and operations in the where clause. But one of the comparison which you are going to do is this ingestion time. There's going to be a pseudo column, a column which is going to be generated automatically by BigQuery. You're going to put a where clause on that. Where clause on that. So this is very, very important. Many people partition it, but they don't turn this on. If you don't turn it on, I would say it's of no use. So make sure you turn this on explicitly. Very, very important. And you can partition it by different types, basically date, hour, month, year. So if I meant by day means it's going to take today's date, 25th of April. If I do it by hour, it's going to be taking like maybe I'm uploading every 1 hour a data. So it's going to take 25th April and 2 o'clock as my partitioning time, partitioning field. So year month will not be useful in our context. So if you're going to upload once in a month, then you can go with that basically. So that is what this indicates. Basically what we used was we tried to use auto detect for the first time. We see some changes later. We'll see some changes better. So if you use auto detect, you only see these options only. So I'm going to go with the first option, which is partition by ingestion time, and I have turned on the filter so that I can put a where clause, and I'm partitioning it, basically grouping it by hour, every hour it's going to do it basically. So if you upload, keep on doing it. So that's the setting. And since it has a header, let me skip this header. That's it. Now let me click on create. So let me see whether there's a header. Yeah, I have a header. So click on create. Awesome. The table got created. Where's my table? Yeah. Now you see other tables, and this table is an outstanding table. It looks totally different. It does not look like a calculator kind of a stuff, but it looks like a sandwich. It's basically just showing that the content is partitioned. So that's a small icon representation which is going to help you out. So more like a sandwich kind of a stuff. So it indicates it's partition. So now if I click on this table, as usual, because it's a native table, you can do schema, preview, details, all those things. But one important information which you are going to see is it shows that details, folks. This is a partitioned table. It shows you that nice information. By looking at the icon also, you can come to know. If you click on the details also, you'll come to know. So details, you will see something new. You'll see something new information. This is something which we have been seeing from yesterday. Not much difference. But this is an additional information, metadata information, which you get where it says this table is partitioned. Now, if I go to the previous tables which we created so far, if I click on the employee table which we created yesterday, no information is going to be there. It's a normal or a regular table or a non-partition table. But if you click on the one which we just created, it's going to be a partition table, and it's going to say partition by hour. This is what we mentioned. And there's going to be a pseudo column or a field called as underscore partition. So if I just mouse over, it shows this is a pseudo column that contains a UTC date that partition was loaded. And we have mentioned where clause required. What does this required means? I'll show you that in a minute. What is the importance of it? Now, if you click on preview, it looks the same thing, folks. In a normal preview, you will not even see any difference. And the pseudo column will not be also shown here. That is the reason it is called a pseudo. These are regular columns, you can see it, but this is a hidden column. Hidden column. Now, if I click on query, I put first name. If I put first name, now whenever I query a partition table where this partition filter is required, I have mentioned means it is going to automatically put a where clause, folks. It's going to put automatically a where clause. If you see some other table, for example, which is a normal table, if I click on query, it's not going to put that where clause. But if it's a partitioned table and that too you have turned on partition filter, if I click on this, it's going to put automatically that where clause. So that's the important thing. And if I remove it, it's going to throw me an error. So now if I just query, get me all the details of the first, let me get the details of the first name of the from this table where partition time is today. Today is what it indicates. I can remove limit. It's not going to incur any value here. So it's going to show this is going to process around 68 bytes of data. So let me try to run it and see what is going to happen. It shows that information. That's it. Now, if I remove this, if I remove it, it throws me an error, folks. It throws me an error where cannot query table because partition can be used for partition elimination. So it shows that it is going to be a mandatory one. Now, this putting this filter makes it very effective. It forces the user to put always this clause. You can put n number of other clauses, attributes, but make sure this is one of the clause. So if I just format this, you can put one more clause, say for example, and first name, like starting with A. You can put that, but this clause is important. So if you remove that one, it's going to still throw that error. So one of the conditions in your where clause is has to be your partition time, typecasted it to date because it's going to be in time format. So it has to be typecasted to date format, and you put that clause. So this is very, very important. So if you don't put it, it's not going to allow you to query. Now if I query it, it's going to basically send me the results, which is only going to be starting with A. So far, is it clear, folks? The advantage of partitioning. I'm going to go a little deeper with the partitioning stuff once you are okay with this part, which we have seen. Thank you, Mangesh. Others, is this concept clear, folks? Thank you, Kumar. Now, a little internal stuff, folks. A little internal stuff. How this partition. Thank you, Deepak. So how these partitions are actually stored. If you're very curious to know, we'll explore something called as legacy commands in BigQuery. Legacy commands in BigQuery. You can see that in your cheat sheet also. This one. So you can use this kind of a command. I'm going to use this in a minute, where you will see this entire detail, how partitioning has occurred, the details of partitioning, all those things. So let me just copy this command. Now, before I run that command, this type of commands, right? If you see, I can, the single quotes or quote, whatever you want to call, smart quote or something. So if it is starting with this, it's basically a command which runs in standard dialect. There's going to be some couple of dialects which BigQuery offers. Standard dialect means this is the normal SQL style. Google also is also having something called as legacy dialect. So if I click on this gear icon, query settings, you see lots of options. One of the option is SQL dialect. So use standard to run queries in BigQuery. There's one more option called as legacy. So if you put this legacy, you can run some internal commands on BigQuery easily. So it's always preferred to use standard wherever it is possible, because it's going to be in sync with your ANSI SQL 2011. But if you're using legacy, it is going to be very specific to BigQuery. May not have some specific options or comparable options in your normal SQL. So legacy, use it only when it is required. So the commands which we are running are all standard commands. If you want to know the details, are we running really standard commands or not, go to your query history, click on the command, any of the command, it should show legacy SQL is false. So it's all currently standard SQL. Now what I'm going to do now is show editor. So what I will do is I'll just get this name, folks. Sorry. Copy this table name. Okay, let me just zoom this a little bit for a better view. Now if I put this, it was just a copy paste from it, where I tried to see some partition summary. I wanted to see some partition summary details. I tried to put this kind of a query. The moment I put this kind of a query, right, it's going to say some errors. Because it is not a standard dialect, you have to make it as a legacy dialect. Only then it's going to work. So let me try to do it by clicking on the clicking on the query settings, change it to legacy. Now the command becomes valid because querying your partition summary details and all is going to be a legacy command. So you have to use this legacy SQL dialect. Now if I change it back to standard, it's going to again throw me the error. Most of the SQL statements which you are going to run is always going to be standard SQL only. Only when you wanted to get the internal details, all those things, you can use legacy. Now, either you can every time you can go click on this gear icon, query settings and do it. That's one way. And but if you want to do a little smartly, you can put a specifier called as legacy. You can put this kind of a specifier. It automatically works, folks. So this is latest easy, right? So sometimes people don't like to use mouse every time. So instead of that, you just type this specifier. That's all good. So it's going to be set. Now let me run this and you'll be really surprised to see the output. So this is the output of that summary partition summaries table. What it indicates: the project ID, the data set, the table name which you partitioned. Now this is the partition ID, folks. Can anybody demystify this partition ID for me? This is the ID, creation date, so and so, blah blah blah. But can anybody demystify what is this format? In what format it is in? 25th of April. Okay. What is that 02? What is that 02, folks? It is the UTC time, folks. It is because you partition by hour, right? Partition by hour. So maybe if I see the time now, it's going to be around 24. So in after 36 minutes, if I do one more insert, it's going to be basically the same thing ending with 03. So every 1 hour, it's going to create one partition ID. So you are going to use it. So that's going to be your ingestion time because you are going to use partition by ingestion time and that too by hour. So this is how your partition ID gets created, folks. And you use this to query it. Basically. So this is the key part. Now, as more data you insert, you are going to have more partition IDs and you are going to rely on this partition ID to query it. Basically, this is the internal working of it. You may not appreciate it now, but when we do the next part of the demo, you'll really appreciate it. Why this partition, the partition summary concept is going to be helpful. So now what we will do is we explored partitioning in one concept, basically using partition by ingestion time. Now, that is only used when a data set does not have a date field or an integer field kind of a stuff. But in our data set, we have it. But since we used auto detect, I was not able to do that. Now, I'm going to do one more demo where I'm not going to use auto detect, but I'm going to explicitly mention my schema, and you'll see a huge difference in the user interface. And then we can use a specific field, maybe the joining date, as my partitioning field. So let's see how it's going to work. So for that, again, create a table. So same data. Now I'm going to call this as employees underscore PT, partition table. And we are not going to do the mistake which we did of selecting auto detect, but we are going to use our schema, which we already have it. So I'm going to use this. So now I have mentioned these are the schema. Now there's an integer, there's a date and a string. Now if I go to my partitioning, you'll see a new stuff. So this is the stuff, folks. So if you use auto detect, you'll only get partitioning, no partitioning option, or partition by ingestion time. But if you mention the schema explicitly, it's going to show you can do partition by integer, partition by date. So now if I just for a minute make this as timestamp for a minute, just to show you that. So first name is also possible because the type is timestamp. So if I make it as float for a minute, I don't get it. So currently the partitioning is supported by only 3 data types: date, timestamp, and integer. Hope this part is clear, folks. Not every field, if I make it as numeric, not every field is available as a partition field. Only 3 data types are available. Only 3 data types are available. That's integer, date, and timestamp. I'm going to use joining date as my partition field. Now I put the same logic. I want to put a filter, all those things. Now somebody can ask, when we did partition by ingestion time, we get date along with day, month, year. We also got hour kind of an option. For example, if I select partition by this, I got an option like by hour also I got it. But why I don't get it when I use this one is basically it's a date. Date is not going to have an hour field, so it cannot do it. But if it's a timestamp, if it's a timestamp, if it's a timestamp data type, you will get hour also. Hope this part is clear, folks. Like you can get hour partition type only if it is a timestamp. If it's a date, it's going to be day, month, and year. Okay, because that attribute is not going to be there. So let me just make it back as date. I am going to do it by day, and my partition filter, I want it to have it. Simple. So this section, is it clear? Please let me know, folks. Hope it's making sense now. The whole reason is because you have put explicitly your schema. Thank you, folks. Thank you. Now, because it's going to have anyway a header, I'm going to use the same thing. Skip it. Click on create. Table is created. So we have 2 partition tables. Now, if I go look into my PT table, the partition table which I created shows it is partition. Good. Details, it shows the same stuffs which we saw, standard one. Under your partition details, it shows it is partitioned by partition table. It is partitioned by day. Now you will not see that pseudo field. You will not see that pseudo field because you have explicitly mentioned, I want to partition by, group it by a specific field called as joining date. And the filter clause is also going to be mentioned. If you're looking at the preview, no difference. It's going to look the same. The only difference is going to come when you query it. Let me query it, folks. Let me put first name. Now when I do this, let me make it big, put it format. Now I can remove this filter. Now this is on my new partition table where the partition field is joining date, and that's the reason why that where clause is saying that. Now before I run it, because it's a native table, I can always leverage this value. It is showing 0 bytes are going to be processed. Any reason why, folks? I can run it and get the result. I can know what is the reason why it is showing 0. But before doing that, any reason why this is showing 0 bytes? It's not an external table. It should have given us some results. Any reason why it is not showing that, folks? Any reason why? Maybe to help you, I can show you the preview option. This is my preview. Yes, Mangesh and Anil B. So basically, nobody joined the organization today. That's the main reason. Nobody joined today. You see, you are putting a where clause where equal to today. So it is not anything there. So if I put a where clause, anything less than this, anybody joined less than or equal to this, then you will get this data. You'll get this data. Okay. So now let me query it. I should be able to get my details. I'll get my details there. So basically that's where that where clause comes very, very handy, and make sure you put the right time there. You should get it. Now, the now important part is if I go and use this partition summary concept, you will see something very nice. You'll see something very nice exploring it, because if you see our data had something like this, 3 set of informations were there, because we had done partition by day. 28th of September 1997, 23rd of January 1999, 22nd of February 1919. So there are 3 days in our record, in our tables. So you should have 3 partitions basically. So to see that in action, let me copy this syntax. What I'm going to do is I'm going to copy this command, cut this, it's going to throw that error. To fix that, I'm going to put this specifier legacy. The moment I put it, it's going to come back to that. Now when I run it, you will really appreciate the output. You're going to have 3 partitions, folks. You're going to have 3 partitions. You see, one on 1997, 28th of September 1997, 23rd of January 1919, 1999, 22nd of February 2019. So hope now things are becoming much clearer, folks. You see more partition IDs, which is going to help. Now we have not seen the performance impact. We have just understood how partitioning works basically by literally doing a demonstration. Once you understand the concept, we will use this concept on a bigger data set. There you'll see the performance. A query which took longer time could be taking shorter time, or it's going to take less amount of data to be processed. So till here, is it clear, folks? Where you see how many partitions, you can easily make it clear that the number of partitions are created are 3, because your data set had that number of data. All right. So now what we'll do is, we understood how partitioning, the concept works on a smaller data set. Now you can see it, the value is going to be there only if it is on a larger data set. So, and I don't have a larger data set, so I'm going to rely on my public data set. So we'll rely on an existing public data set and see how we can leverage partitioning on it. Okay, so the same concept we are going to use it. So by doing this, you will also learn how you can copy the data set from a public data set to your project. All those things you can also see it. Okay, so let's explore that. And this entire syntax is going to be little difficult, so I've already put this in the cheat sheet. On the cheat sheet, you can go use it. Copy paste is going to work. I'm also going to do the same thing. So we wanted to understand the concept basically. So the syntax is not at all important. You can have your syntax, you can just search it, you can get it. But one thing with respect to the syntax, which could be a possible question which Google in exam they may ask, is very basic, but may look little tricky. So sometimes they may ask whether this table is a legacy table, which you're going, is the query a legacy query or a standard dialect. So you may miss it if you're not from the database background or a warehouse background. So legacy dialect always starts with square brackets. Standard dialect always starts with quotes. So now a small trick which I wanted to make you to remember is you look at L, folks. L and the square bracket almost looks the same, right? It's more like a child learning a pattern. So L and square bracket looks the same. So this is how I, in my beginning days, remembered legacy versus a standard SQL. So if it's starting with a square bracket, it's always a legacy command. If it's single quotes or even no quotes, it's going to be standard dialect. So small tip, at least going to help you out in the exam. If they say, is this a standard SQL or a legacy SQL dialect? Legacy SQL dialect starts with a square bracket. So square bracket. So I'm just going to highlight this letter and this one. And standard dialect in BigQuery starts with quote. Could be helpful only from the exam perspective. Basically, syntax is somewhere close to BigQuery. Date is similar to okay. Syntax. Which syntax, Mangesh? Is it the legacy one or the standard dialect one? Standard SQL dialect. Which one is similar to IBM? Oh, standard one. Then that's basically because IBM DB2 is also ANSI SQL 2011 compliant mostly. So that's the reason. The legacy one is going to be totally unique because that is GCP's style. They started with legacy, but they felt that people need to learn something new syntax. So they created a new dialect. So now what we are going to do is I have to zoom this off, clear it. Yeah. Now we'll explore partitioning on a larger data set. Partitioning. Then once we understand partitioning, we'll go to clustering. Then lastly, our how do we expire a specific partition? We'll also see that. That's going to be the cool demo, I would say, with respect to that. So for this, I will use a data set which is a public data set. So this is what I'm going to use without any partitioning, how much it's going to take. After partitioning, how much it's going to show. That's what we wanted to see. So I'm just going to copy this, folks. Direct copy paste and run this. Now you may see something like this. What is this error, folks? What does this error indicate? Any thoughts, folks? What does this error indicate? Use standard SQL is what it is saying. Yes, Sridevi. So, and Mangesh also gave that. So it was basically you are using single quotes or quotes. So you have to use basically standard SQL. So meaning you have to click on format this thing. You have to change it to back to this. Then only it's going to work. But I'm lazy enough. I don't want to do that. What I will do is I will use another specifier, folks. I'll use standard SQL. Now fixed. So there are two ways. Either you click on that gear icon, go go select that, or if you want to switch between legacy and SQL, use this specifier. Okay, a small trick. Now this is a public data set. Now the reason why I did not use this preview option, the preview features of BigQuery is only for this demo only. So now a small tip is whenever you are exploring any data set, any table, use your control button in your keyboard, or if you're using a Mac, you will have something called a CMD. Use that. So when I press it, you see the table gets highlighted. I'm just pressing my control button, either of the control, left or right side of the control buttons which you have. It's going to highlight it. Now, if you take your mouse there, click on it, it's going to show the table, folks. This is a very, very handy option. So somebody gave you a query, but you don't know the schema details, all those things. Press control, click on this. It's going to show you basically the table details. It shows you the table details. Now it is basically a table which most of us, or the website which most of us rely on our day-to-day work, Stack Overflow. How many of us would have used it? Every time we use it, right? If we have any issues, we search. Most of the time the sources from Stack Overflow can be relied. So somebody like us would have got a problem, they would have fixed it, they would have shared that information. So that data, Google has pulled it and created a public data set called as Stack Overflow post, where various informations are there. Around like 15 columns are there. Looking into the details, it shows it is having, for the first time, folks, from bytes to kilobytes to megabytes, we have come to GB. So it's almost like 30 GB is the data. So yesterday we only saw 7.5 GB of data. Now we are seeing 30 GB of data. Total number of rows are going to be 31 million rows. So it is in US data location, US. Now this one is basically a multi-regional location. A multi-regional location. The reason is it is just showing US. If you look into our data set, it shows Asia Southeast 1. Basically, it's a region. This is a multi-region. This is a multi-region. Looking into the preview, you will come to know what is it. Basically, people ask questions on Android. People ask questions on Java. They would have asked lots of questions, basically. So this is the data. Now, what we are going to do is, first and foremost, we are going to basically run this query. Run a query to get the title, the questions which they ask. Title, basically, it should look like the title. These are the titles. So we wanted to query this column. We wanted to query this column from this table with a specific time range. There is a date field called as creation date. So if I just go to my details, create date, where is that? Yeah, where is that? Yeah, this is a timestamp, folks. It is a timestamp. So what they do is they do a typecast and they do between 1st of January 2015 to 31st of December 2015. In 2015, get me all the details of the title. What kind of queries people raise in Stack Overflow is a question. So if I run this before the question, stuff is already valid syntax. It shows 840 MB of data you are going to process. So if I run this, it's going to take a couple of seconds for it to run, and amount of data which I'm going to process is going to be 840. 840. This is on a regular table. This is on a regular table. So it took roughly around 9 seconds for me to process it. It is very clear it processed 840 MB of data. It's a regular table. Now we are going to apply our concept which we have learned on this table and see whether the amount of data which you are going to process, because you are going to process only data set which is a 1-year data set. This may have a basically how many rows it got. I can get to know the details. How many rows it got. So how many rows it got was basically around 5 million out of 31 millions. 5 million rows was what was retrieved. So okay, here also I can see it. Sorry, I can see it here itself. So I have done some. It's basically a normal SQL query which you have put and you have got the results. Now what we will do is, how can we reduce this using the concept of partitioning? And we know partitioning can be applied only for certain data types. maybe we can use creation date itself as our partition field, because it's basically a timestamp which is a supported data type. So now what we are going to do is we want to make it as a partition table, but you cannot convert this regular or a non-partition table which is in this project BigQuery public data set. This is a project ID, folks. So this is provided to you free of cost. They have stored it 30 GB of data. They have kept it in their project. They have given you access to query it. When you query it, it's going to be charged in your project, but only the data storage is in their project. So it is like a different model altogether. I share the data with you. I host the data, but when you query it, it's going to be built in your project. A nice option, actually, a nice option. Questions on this kind of a stuff also can come. Basically, we'll do this demo also at a later point of time. So the data is a public data set. It's only read-only access. I cannot even modify it because I want to do it as a party. I need to convert this into a partition table. So basically what I have to do is I have to copy this to my own project and partition it. That is how I can do it. So if it is in my data set, I can do whatever I want. So the public, I cannot do it. It's a read-only stuff. So to do that, what we are going to do is we are going to learn one more command where we are going to create a project. Create a table. Create a table and copy the complete 30 GB of data to our table. Once it is in our table, we can do whatever we want, and basically certain stuffs we are going to mention. You want to partition it by creation date, you want the filter to be there, the where clause. That's it. That all things are you're going to mentioning it. So now I'm just going to copy it as is. I'm going to copy it as is. Now this is a create table. We are creating a table actually, so I don't want to mention the project ID because I'm already in the project. I don't need to mention it. Now there's a data set. I don't want to use that data set. I want to use my own data set. So if I do something like this, batch 6 underscore ds. So when I do something like this, right, it throws me an error, folks. It throws me an error. What it throws, right? No data set found in location. So this data set was not found in Singapore is what it mentions. It mentions it is not found there. So again, the same concept. You cannot copy the stuffs, all those things. The same thing applies here because this data set, if you see, is this data set is in US. So you cannot do this way. So you cannot do it this way. So if you have a data set in US, the copying is going to be possible. So that's the reason what we are going to do now is we are going to create a data set in US called as Stack Overflow. Create a data set in Stack Overflow. Sorry, create a data set with the name Stack Overflow and put it in US. Now, when I mention any data set with the name hyphen, it shows hyphen is not allowed. Maybe they could have put the same logic even for the tables, but they don't put that. But you can use it, but with sometimes when you do it with an ETL tool and all, hyphen is going to have some problems. So always use underscore. So, and I'm very sure this 30 terabytes, 30 GB of data, which I wanted to do now, I don't want it anymore. Only for one day only I want to keep it. So tomorrow itself expire it. I don't want to keep it because it's going to incur cost for me. So I'm smart here to save some cost. If there's any ad hoc workloads which you're going to do it this type. So now I have a data set created in US. So if I click on it, is going to expire in a day. So I don't need to even clean up the stuffs. So if I just leave it, tomorrow it's going to be automatically, the 30 GB which you are going to copy is going to be automatically removed. Now what I'm going to do is, I'm going to change this to Stack Overflow. It should be a valid data. Now what it's going to do, it's going to copy it from there, create a table in my data set, which I wanted to make this table as a partition table. So here, this is a non-partition table in the actual source, but when it gets copied, I'm making it as a partition table where the field is going to be creation date. I do a typecast to date and also put a where clause filter requirement. So now let me click on create run. It's going to take around 40 seconds or 50 seconds or close to a minute to create a table. Still running.
So Mahesh, earlier you used to create manually the table, right? Is there any reason rather than that you're using the query and creating a table?
That was a table which we wanted to create from the scratch. So this we wanted to copy, that is, we wanted to copy the data, an existing data from a public data set to create here. So that's the reason. So that one is, you can use, basically you can create table there also, the same stuff there. Here I'm basically using my SQL commands to create it. The reason is I wanted to copy an existing data into a new table basically. And this option of create tables which we have does not allow me to copy an existing one. So I have to usually load it from a source, local machine, or from a storage bucket. Here, this is in some other BigQuery table. From a table to table copy, I'm trying to do. So in that case, I have to do this option, Mangesh.
Okay, so you
Sorry,
know need
Kumar.
yeah, so you need to you need to download that data into some storage bucket and that.
Yeah.
Yeah, okay,
So
got you,
if you
got
want to
it.
do that style, you have to do that way. But here
Yeah,
I wanted to do, because we have done that. So I thought
yeah,
I'll share you a different approach also. So if you
okay,
have a data set, you want to try it, you can do it. Now I have my data set. So if I just hide this, so it's the same schema, looking at the details, same 30 GB of data, same 31 million rows, everything is going to remain same, but the additional information is, now it's not a non-partition table, but it's a partition table. So it's no longer a non-partition table, it's a partition table, and the partition field is by creation date. So far everything is good. Now what I'm going to do is, I'm going to copy the same command which previously we ran, which took around 840 MB of data got processed. Now let me run it one more time just to show you. It's going to show the same thing. It's going to show the same thing. Now it should have actually read from cache. Sometimes it reads from cache, sometimes it does not read. So I'm not sure what is that logic behind the scene, but it should have read from the cache. That's not a concern now. The concern now is, you ran this table, ran a query on this table. It almost processed 840 MB of data. Now I'm not going to do any change to this query, folks. What I'm going to do is only one thing. Basically, I remove this line. What is this? Project ID. So I'm going to remove this. If I don't put that query, do I have? So I have to remove this name. Or let me put it like this. I'll just comment it. I'll comment this and I will use partition. I'll use Stack Overflow. Yeah, I'll use this, folks. You see the difference? if I comment this one and use a normal table, the public data set, it's saying it is going to process 840. Now, if I comment that and use this one, the partitioned one in my local in my account, it's saying it's going to process 167. You see a huge difference. All credit goes to your partitioning because you have grouped it by that. Now, if I run it, it's going to be literally that 167 MB of data only is going to be processed. So let's just see the results. You see that, folks? Same amount of data. So it has reduced the amount of data. So if I reduce the amount of data, meaning my cost reduces, So now you may say the titles are null. The reason is the sorting would have gone differently. So if you want to put some logic there, something like and title is not null, something of this sort, it's going to show only stuff which is not null. You can put that also. If I put, you'll get all the titles which is not null. So because in the original data there were some titles which was null. So now when you run it, you should be able to see all titles which is not null. Basically, the key part here is the amount of data which you are going to process is going to be reduced because of partitioning. So now if we use our basically our partition summary table, right, the concept is going to be become much clear. So let me just do this and then we'll take a break. So if I go back to my partition summary, I'll just query this one. It's going to be a legacy one. I'm going to use my specifier. Okay, let me just query it. Now you will really appreciate the output. You see the partitioning, folks. So the data which Google provided, the 30 GB of data, has records from 2008. From 2008, every day there is one partition which is created. So almost there are 2,874 partitions created, of which we queried a specific partition only from 2015 January 1st to 31st of December 2015. So hope this demo help you to understand the concept of partitioning, folks, along with this partition summary details, which is a legacy command. So that's on the partitioning part. Any questions? Let me know, folks. Clear? Not clear? Amount of data which you're going to process is going to be less. If it becomes less, amount of the price which you're going to pay is going to be less. Basically, that's it. That's the key part. That's the main reason why we did partitioning. Nothing else. You saw it by yourself. So from 840, it just came down to 160, 160, or 167 or 170, basically. So thank you, Mangesh. So if you don't respond, folks, I'll take it as yes, things are clear. I'll take it to my advantage. Only if you ask questions, only I can understand, oh, there's something is wrong, I can explain it. So if you don't respond, I'll take it as it's clear. Okay. So we'll stop it here. We'll take a 10 minutes break. Once we come back from the break. Yeah.
One small question.
Yeah, come on.
Will there be any price increase or anything because of the partitions? If the partitions are increased more than 5,000, more than 10,000, something like that.
Sorry, come again. I missed the first part. Is there any on me?
Is there any price increase? Yeah.
No. Price wise, nothing. So it's going to be just a storage. So there's no, and if you see the pricing calculator, right, it is basically based on only two attributes. So so if you see the on demand, we are doing on demand. So how much is your storage, how much you have stored. I have stored 30 GB. How much you have queried, that's going to be the stuff. So there's no other details which is going to be required. So it's only going to be on the storage cost and how much you're going to query it. So there's no cost implication if you have more partitioning, Kumar.
Okay, got it. Thank you, Mahesh.
All right, folks, I'll stop it here. We'll take a 10 minutes break and come back.
This conference will now be recorded.
So before the break, we saw how partitioning works on a larger data set. So that was all good. And if you start now, this is where your database expertise comes into picture. Now, people who have worked on database will say, this is all good, but it lacks the key feature which other, actually, it's not good to compare a database with a data warehouse. But if you still do that partitioning, in normal databases, you can partition it on any field, if I'm not wrong, string, float, whatever it is. But in BigQuery, it has limitations. So how do we overcome that limitation? Is with a concept called as clustering. So you basically do what? Say, for example, if you were to group stuffs based on a field which is a integer, sorry, which is a string. If you were to do that on that kind of a stuff, you cannot do it because string is not a supported data type for partitioning. We saw that. You can also look into the demos documentation. It's only 3 fields: timestamp, date, and integer. But if you want to do on a string, what you should do basically is first apply a partitioning on a table, followed by clustering, which is basically grouping. Basically cluster it on that specific string data type. That way your uh, limitation can be overcome. This is just a workaround solution basically. So if you want to partition it, there could be an interview question also. So if you were to partition it on a string data type in BigQuery, there's no straightforward answer, but it's going to be a workaround where you first partition it by maybe a partition by ingestion time or by some integer or by some date fields. Then on that table, you do a clustering on that string field which they want. So that's how we are going to do. So let's do the same thing by doing the demo where same data set where I'm going to use the same time, all those things, and I'm going to put a extra where clause also where I wanted to get only data which is something like having a tag called as Android. So any questions related to Android, only that I wanted to add is what I want. Only that I wanted to see is what I'm saying. Let's give a try. How long it's going to take, how much data it's going to process. So again, the same error. Okay, some copy paste issues will be there because of that quotes. Make sure you fix that part. Query, sorry, like standard query. Now it shows if you were to have this amount of data, it's going to like with this clause, all those things, it's going to take around 1.2 GB of data is going to be processed, is what it indicates. Let's just verify it. All right, queried around 1.6 seconds. It took 1.2 GB of data process. So 1.2 GB of data was processed. Now what we are going to do is tag. If you just look into this field by looking in the details, tag is basically an integer data. Sorry, it's basically a string data type. So clustering is a good fit for this. So what we are going to now do is first make this table partition by on the same field creation date, then also cluster it by tag. And you can do up to 4 data types. You can do 4 data types cluster. So clustering on 4 data types are going to be possible. So basically non-integer, non-date, non-timestamp fields you can cluster, and you can use up to 4 fields. Basically, that's the upper limit. So let's try to do that. We are going to follow the same procedure where we are going to create a new table. This time, along with partition by time, we are also going to add one more clause, cluster by tags. The tag field which is going to come from this table. That's what we are going to do. So let's create this. So compose a query. So I don't need to mention the project ID if I'm doing it in the same project. So this is what I'm going to do. So in a Stack Overflow data set in my own project, I'm going to create a table called as partition underscore clustering underscore demo, which is going to have partition by a specific field, and I'm going to cluster it by a tag, a non-integer, non-date, non-timestamp field called as tag, which is a string data type. That's it. Let's go ahead and process it. Let's just wait for a minute or so for it to finish. Okay, it took around 46 seconds to process this. Now I have a table partitioned plus clustered. So if I click on this, it's going to show it as partition table. Only if you click on the details, you are going to get it is also clustered by a tag or by a field called as tags. So everything looks the same stuff. Now what we are going to do is we are going to do the same query. The query which took 1.2 GB, which processed 1.2 GB of data, is going to now process only around 250 or 235 MB of data because of partitioning and clustering both. And you cannot directly cluster the table, folks. First it has to be partitioned, then only you can do the clustering. Remember that. Now I don't want to copy this. I wanted to show you a different trick. How do you run the previous commands? So if you have run a command which it works successfully, go to your query history. You should see your query here. This is the query which you ran, right? So you can just click on open in query editor. So you'll see that stuff here. There's a question. I'll answer it once I finish this part. So this is the query which is going to query basically your public data set. It says it's going to be 1.2 GB. Now what I'm going to do, the same trick, I'm going to comment this line. I'm going to do Stack Overflow partition class. So now from now if I just comment it back, if it is the public data set, which is non-partition, non-clustered table, 1.2 GB data is going to be processed. If I do this one, which is our own table, which we partition and we also clustered it, it's going to take around 235 MB of data. Let's verify it by just running it. Yes, okay, it took the actual data. That's a dry run, folks. That's a dry run. So the actual data it took was only 216 MB, 16 MB only. So, and all the stuffs are going to be basically related to Android kind of stuffs, basically, because you have put a clause. I want only in the title, it should be Android should be mentioned. So it's going to give you that. Now you see the real value where you can use clustering and also partitioning concept together to get it. Now there's one question from Vivek. Will clustering increase the storage cost? So a good question. Now if I just show you, go back, this is the normal table which you had. This is a normal table which you had from the public data set. It was 29.36 GB is a total table size. That's your storage size. Now, if I go to my clustering-demo table, if I go look into the details of it, it's going to remain the same. So to answer your question, it's not going to increase any storage cost. It's basically the way the data gets stored. So it's very simple, folks. Now, if you have a very structured way of storing your files, assume you are a person who like to read lots of books. You have all kinds of books. Maybe let's take, for example, cloud related stuff itself. You have around 10 books. Now, if you arrange it very properly, you can get it very easily. Only one shelf. In your home, you have only one bookshelf. You can keep it in a very ordered manner so that you can pick when you want to read AWS, you pick it. When you want a GCP, you can pick it. But if you just put it wherever you want in the shelf, you're going to spend more time to searching it. Same concept, same storage space, same shelf space, but the way you arrange it, in that way you're going to quickly read it. That's the basic stuff. Okay, so that was an interesting question, Vivek. Now we have seen basically clustering on large data set, partitioning on large data set. Let's see the last important piece, which was the whole reason I wanted to show this all partitioning concept was basically, now if you say, right, even if you look into any official documentations, or sorry, official course materials, they would not have done this much of details on BigQuery, because recently the BigQuery is going to be dealt in detail for data engineers, not for architects. But the reason why I went a little deeper is I have seen off late the number of questions, at least in the from May 1st, you're going to get a new set of questions altogether. At least the last time it was refreshed was on November 9, 2018. Before to that, I have heard from people 1 or 2 questions used to come. But when I took my exam first time in 2018, before to this taking this exam, I had finished my data engineer course, so I had cleared it. So I had a good exposure on BigQuery. To my surprise, in my cloud architect concept questions exam only, I got around 6 to 7 questions on BigQuery. That's where I understood the concept. People are expecting, or Google is expecting you to know more BigQuery concepts. And I have done trainings for other organizations also. And they provide their own course material. I have to just use it and just do the training. Some organizations don't even have BigQuery slides itself. Some way they have very high level stuffs, so they don't go deeper. But I felt, because I had taken the exam, I felt questions on partitioning came. So without you knowing what is partitioning, I cannot directly jump into a demo where I show how to expire a partition. So that was the whole reason why I did this more detailing, which may be little like an overkill, but maybe more questions on BigQuery can still come. So Google expects you to know a basic knowledge of what is clustering, all those things. So I can just put it in slide, but I thought I'll share it in a demo fashion. So it's going to get registered very well. Now let's do one last part, partitioning by expiring the table by a partition date. Now you may say we explored yesterday itself something of this sort, but what we explored there was, folks, so if I go to my any of my tables, it says the entire table is going to expire on 28th. I don't want this. In some cases, it could be helpful. If it's an ad hoc workload, like the one which you just did, you wanted to explore partitioning and clustering concept, one day expiring is all good. Expiring it by a day is all good. That's all good. But assume it is like a GDPR requirement where you have a clause, any information, I need the table, but any information which is more than 90 days old, meaning a partition which is 90 days old, delete it. A partition which is 1 day old, delete it. But table should exist, other data should exist, the schema should exist, not the removing the entire table. So that is what is very, very important. So ad hoc explorations, putting a filter at or creating a data set with an expiry time is a good choice. But in some scenarios where you want to expire only a specific partition, this next demo is going to be really helpful. And I had got this question in the cloud architect exam. So in 2018 when I took it, so I thought let me at least share you that syntax so that you will be aware of how to do this. So for this, we will basically use our command line. So we have done a good amount of exploration in UI. Why don't we finish off it with a command line? So there should be a syntax which you can copy. This is the one, folks. This is the one. So what we are going to do is we are going to load the data, BigQuery, Cloud Shell, that content. We are going to load that into a new table called as expire soon partition table. This is the name of the table which we are going to do. But we are going to also mention what we are going to do is we want to partition it by, if you don't mention any information, it's going to be by default partition by ingestion time. If you mention these details only, you want to partition it, but you don't mention any other details, it's going to be partitioned by ingestion time. And we are mentioning we want, this was a syntax, folks, where you will see basically about when the partition should expire. I'm mentioning a details where the partition should expire by 24 hours. So partition by basically by a 24 hours. You can do it by year. So you have that options, right? We have seen it. So what are the partition by you want to do? So you have different types basically. So if you want to make it by year, you make it here as year. That's it. Month, day, hour. You have all 4 options. You can do that. So let me just use this to create a table and show how it's going to happen. So I'm just going to use data set name. I'll just change it. Batch 6 underscore DS. Vivek will talk about streaming in next Saturday's class. How BigQuery streaming works. I'll show you that. What is streaming buffer? We will see that in next Saturday's class. Now what I'll do is I'll run this query. So the whole important stuff from the exam perspective at least was this command, folks. This is the command which came to me basically. So I wanted to highlight that basically. So where you're going to expire the partition every basically what? Every 24 hours you are going to expire it. So any partition which is older than 24 hours will be automatically removed. But the table exists, the schema exists, any new data are going to continue to exist. That's what is going to happen. So let me hit enter. Done. The table is created. Now if you want to know the table, you can do BQ ls. It's going to show you 2 data sets which you have. Now we created a table in batch 6 data set. So you can put ls batch 6 ds. It's going to show you some nice user interface which the UI cannot show you. So it shows all the tables. It shows beautiful things like this one. It's an external table. Mumbai is an external table. Wildcard was an external table. Now partition, which we saw, it partitioned by day. The field was this one. The other one, if it is partitioned by ingestion time, it just shows it does not show you that pseudo column. It does not show pseudo column. If it's not showing the fields, it's basically a pseudo column. It's basically a pseudo column. Now the one which you just created, expire soon table, is a native table. You are partitioning by day, and the expiration is every 24 hours. Every 24 hours. So you can go ahead and query it. We never queried it in the command line. So let me just query it in the command line once, because we always did loading, but we never queried it. So BQ query.
Excuse me, Mahesh.
Yeah.
Which one is the pseudo table? I was not able to hear it properly.
Sorry.
Which one is?
Sorry.
Which one would be pseudo table?
No, come again. Sorry, Vivek. I did not understand.
Now, which one will be a pseudo table? I was not able to.
Okay. Now, if you see this one, there's a partitioning already. So this table as having, it's a partition table is what it. So look for this column, time partitioning. So if you see this table, it says it is partitioned by R, but it does not share you the details of partition by what field. If you don't see that field information, it is going to be basically using a pseudo column. Here it is partitioned by date, but it explicitly mentions I'm partitioning by joining date. Here there is empty. If it is empty, it's an indication it is using pseudo field or the pseudo column.
Okay.
Yeah. That's a small indication. That's it. So if you want details, you can definitely look into describe the table. For example, if I show batch 6 underscore ds dot this table. Okay, the command line does not show you that. Okay, it does not show that details. But in the UI, at least it will come to show. It will show you that it is having a pseudo column. So the command line is not showing it. Expire means the table will drop, or only the partition will drop. Only the partition will be dropped. So in our data set, Mangesh, when we mentioned expire the table after 5 days or X number of days, the entire table will be dropped. But when you do the partition wise expiry, only that partition expire. The table, the structure or the schema, along with any existing data is going to still there. Only that specific partition is going to go off. Okay. So,
so Mahesh, what does it mean? I mean, for example, after 1 day, the data still will be there in the table. The partition is getting expired.
That's what I'm going to hand. I'll show you that demo. And next Saturday when we come, we'll do this first as our activity itself. So what I'm going to do is I've already created the table. So now if I just go here, if I go here to my expire soon, where's that? Okay, I have to refresh the screen, folks. I did not refresh it. I'll refresh it in the new screen because I created in the command line, so it's not reflecting it. So if I just go to my BigQuery, what's going to happen? First of all, let me expire soon. Now, if I look into this is also partition table only. You did not mention any schema, so it took the name randomly, some names. You see 3 rows are there. 3 rows are there. Now you see it is partition by day. Because you did not mention any field, it's taking as partition by ingestion time. Expiration, this is the important thing which we have not seen so far. Expiration by 1 day. 1 day is what it indicates. Now if I see, what it mentions is in my setup currently, the table itself is going to go off on 29th of April. So 29th of April is Thursday. But tomorrow at the same time, if I come and see, I will not have these entries because these partitions are 1 day old. But my table is going to go off on basically 29. Now what I will do is I will do an override. So I'll click on this edit option, where because for our understanding, right, because 29th we will not be taking a class. So what I will do is I'll mention only this day, only this part, I'll mention it to expire maybe 1 more week. May 6th, I will extend it. Meaning, when we come on Friday, next Saturday, when we do the demo, the table is going to still exist, but the schema is going to exist, but you will not see these entries. Okay, so that's what is going to happen. But when we come back next Saturday and see, none of this is going to exist. Only one table is going to exist, which is expire_partition table. Does that make sense, Kumar and others? So everything is going to go off because all other tables are going to expire on maximum 29th, or today if we had created few things, everything is going to expire maximum by 29th of April, which is going to be Thursday. So meaning when we come, only one table is going to exist, only this one, because we have changed, we have overwritten the specifications. It should not expire on 29th or 4 days. We wanted it to expire on 6th of May. Only this table is going to exist in this data set. There's a question.
Is it possible to make the table permanent?
Yeah,
Partition
okay. You can just, you don't want to make it never expire, make it never expire.
Okay.
That's it. That is also possible. Your choice based on your requirement. It's not always mandated to expire it, but if you want it, you can make it never expire. It's going to be there always till you explicitly go and delete it.
And is it applicable for partition?
It is applicable to partition in the sense, what is that? You don't want to delete the partition.
Yeah.
That is basically what you did for your normal partitions, right? Like your first one. Now, if you look at the first demo which you did, you never put any expiry.
Okay. Yeah.
So for this specifically, because I got a question, I thought let me explore. So this one, partition expiry, if you don't mention it, it's going to be there forever, basically.
Okay.
So you can have literally a table which never expires, a partition inside that never expires. That is basically this first demo which we did. Good questions. Any other questions, folks?
So Mangesh, sorry, Mahesh, it means that the data also will be deleted with the partition.
For which table?
I mean, they expire soon because the table only will be there, but there won't be any data in that table, correct? Because you are deleting based on the partition.
Yes. So today, because the partition, now if I just go back, so if I query this one, so if I just use that summary stuff, now if I query this table, if I run this query, right, what's going to show is it's going to have only one entry. It's going to have only one entry. This is the one, because we did partition. We did not mention any details. That expire soon used partition by ingestion time as a default thing and did it. So this is your partition ID. So tomorrow what's going to happen? It's going to see the difference is going to be more than 24 hours. That's what you have mentioned. So only those partition ID which falls, basically those 3 rows are going to be part of this partition ID. So those things are going to be removed. The table is going to continue existing. So tomorrow when you come and see it at this time, maybe I can send a screenshot tomorrow at this time. What you are going to see is table exists, but 0 data exists, no rows. Unless if I, after sometimes if I insert some more data, that is going to exist. But this 3 information, Mahesh, Hari, Suresh, would be removed, Kumar. Hope that is clear. The schema is going to continue. The table is going to be there. Only in this context, the table is going to become an empty table tomorrow at this time. Okay. Hope it's clear, Kumar. Kumar or Mangesh, who asked it? Sorry.
Yes, Mahesh. But I was just thinking, because the data, if you see the data, right, the data, the days you mentioned is like 2019, 2018, and
Don't go with this. Don't go with this. Okay. So here, because you went with partition by ingestion field.
Okay. It's
use a pseudo column. So this is going to be on the ingestion time. Now, if you have partitioned by, now if I partition by this joining date, then it has a different point together. Altogether, it's going to be a different thing, because on what field you have to do, it's going to be different. So
for
here
example,
it's going to be on, yeah.
Yeah, sorry. For example, if I go with partition by with the joining date, okay, and if I mention expire by year, so, then if it is 2021, the 2020 data will be lost, right?
Yes.
Okay. Thank you, Mahesh.
Yeah. So this command was something which was asked in the exam. So I'm just going to add it in the cheat sheet, folks, just for your reference. So keep a note of it. So I only remember this line, not the entire question, but could be something related with this. That's the reason I have added it. So this is going to expire your partition only. The table is going to reside. Now, why don't we query it once, folks? We did all the querying in the UI only. We never did once, even at least once querying in command line. We'll just do this part of the demo and move to the next concepts. So let me query this. BQ, you always saw load command. So BQ query. Now, if I do select, I can copy the command as is, which works here. I can just copy any of the query which worked. I'll use a normal table itself, the first table which you created. First name. Copy this. I run it like this. So if I run it like this, let me see whether it shows me the output. It shows some missing stuff. So try putting a single quotes and see what is going to show as a result. Now it shows you something. Now previous one was a syntax error. This one is showing basically something else. Let me know what is this output, folks. You can just look into it and let me know what is the error here. What is the error here? You will face this problem. The same command worked. You know it. Maybe I can just run it and show you once. It works. But here in command line, it is not working. Any reason, folks? Need to give the project ID. I have given project ID, Anil. You see this? It is there. This is my project ID. Data set is your batch 6 underscore data set. Need to enable standard query. Okay. Here I did not do anything, right? Mangesh. Data set is also there, Kumar. Batch 6 underscore DS employee. Mangesh mentioning standard query. This ran in standard query only, right? In my set the project ID. Project ID has always set. So if I do gcloud echo, sorry, it is set. Does command line only use legacy? Yes, Sridevi. So what Sridevi mentioned was correct. This is little contradicting, or I don't know why Google did this, folks. So by default, the UI uses standard SQL. By default, the command line uses legacy SQL. So little contradicting. So you have to always mention an extra flag called as use legacy SQL false. You have to mention this only then it's going to give you the response, folks. So little contradicting, but this is the fact which you need to remember. People make many times mistakes. This copy it as if it's not going to work. So, okay, hope this part is clear, folks. Let me just put it in the implementation or maybe in the exam cheat sheet itself. So by default, uh, by default, BigQuery. Sorry, let me make it big so that you can see it. So BigQuery web console uses SQL dialect, standard SQL dialect by default. By default, BigQuery BQ utility uses legacy dialect, folks. Meaning, can you help me convert this query into legacy, folks? So this way it works. This way it works. If you don't want to put legacy equal to false, all those things, what you can do is basically, I'll put it in a new tab. What I'll do is I'll remove this. I'll remove this. And we know legacy commands always starts with a square bracket. Try this. It works. So that should be very clear what Sridevi also mentioned. So you have to basically, if you put it in square bracket, it's going to work because by default, BQ uses legacy. Maybe in future it may change, but currently it is like this. So is that part clear, folks? You will do this mistake. You'll do this mistake. That's the reason I wanted to highlight very precisely this part. Okay. So if this is clear, we'll do one last part demo and stop it. Now, nobody asked me this, so but this could be a possible question in the exam. Now, whenever you put a query in your UI, it immediately says this is going to take X number of bytes of data, blah, blah, blah. This is called as dry run. By just putting the query, it's going to show you. Can I get something like this in the command line? Is a possible question which you may get also. So how can I do that? Basically, I send a flag called as --, dry run. If I just mention this, what it's going to show is it's not going to run the output. It's going to just do a dry run and tells us how much bytes of data is going to be processed. So now it says 117 bytes of data is going to be processed. So if I take the same query and paste it here, here also it says it is sorry, single quotes. Here also it says 117 bytes are going to be processed. Same is a thing which you get it here. Now this --, dry run is an important flag, folks. Like similar to your maximum bad records, time expiration stuff. Similarly, this could be also a possible question which you may get. So dry run is an important one. So these are important commands. So I'll just copy this. Provides the query cost. Provides the query cost. Okay, so that's something which is very, very important. That's it. That's something on BQ which I wanted to share. So which concludes most of the concept which I wanted to show, and stuffs which I had seen in the exam without disclosing the actual answer question. So I've tried to share you some of the information. At the same point, I tried to also show you some concepts related to the BigQuery. It's going to be little more what is expected for a cloud architect. Only reason is in the future people expects more things from you as a cloud architect, so at least you should be well equipped with it. That was the whole reason. Okay, so now
So my dry run will give the size in terms of bytes and
bytes,
then
yes, it's always goes to give in bytes only. So like what you get it here, so for example, if I get a big query, let me get a bigger one so that you can really appreciate the stuff. So if I let me get this one. So it's around 380 MB. So if I just do this, now what I'll do is run that in a dry run mode. Sorry. One minute, I'll just I have to escape it. Not sure I can do that. Let me just try it once. There should be an option. 1 minute. I'll just remove the where clause for a minute because there's already a single quotes there. There's an escape sequence which I don't remember. It's not the number of rows, it's the amount of data which you're going to process. So if I run it here, it's all. Let me take a different query one. Let me just do this. Okay, it's going to show the results always in bytes. So if you try to do the same thing here, around 867 MB is going to be processed. It gives you the response always in bytes. So you have to use a converter to do this bytes to MB or bytes to MB. So you should be able to convert that. Around 900 MB is what it shows. There's a slight difference there, but it shows that. That's how it shows. It's not the number of rows. That's a dry run just to show you how much of data needs to be processed. It will be processed so that you'll get an idea what is going to be the cost of this query. Okay. Hope that gives you the stuff. We'll give you the bytes only, right? Yes, Mangesh, that's correct. Hope that's clear. I don't know who asked this question. All right, folks. So that's something on the query part, the concept part. Now we saw the slide. The next important thing, which could be asked in the exam, basically, one question came for me, basically related to this in the recent recertification which I took, basically on the rules. Now, before we go to that question, we'll try to understand the concept first. There are different predefined roles. Yesterday, somebody also asked this question: is there going to be a specific role? Yes. What I did, all the demo was using owner role, but not everybody is going to get this role, right? So there's going to be some predefined roles which you are going to use in BigQuery. The super admin for BigQuery, only for BigQuery folks, the role is going to be BigQuery admin, where you get complete access. You can do whatever you want in that. The full access to all the data sets. The second type of role which you get is BigQuery data owner, editor, viewer. So there's going to be a difference between a data owner versus a BigQuery admin. If it's a data owner, to the data set. You will get access to the data set. You can create tables. Everything is going to be possible, but you will not be able to run a query, folks. You can only create data, delete data. But if you want to query it, you need to have a specific role called as job user. If you don't have this role, and or there is a specific permission to that, if you don't have that permission, you cannot even query it, even if you are a owner. So only BigQuery admin, job user, or user will be able to query a data. Remaining everybody will not be able to query. They can handle the data, load it, create, load, all those things, but they cannot query it. That's a slightly a different one here. So let's try to understand each and every role one by one, and then do a demonstration on next Saturday. So if I go to my IAM, and now it is a very clear indication IAM has not stopped. It's going to continue. So if I go to my IAM, and roles section, let me put it on BigQuery. Sorry. So okay, I should have put a better one. BigQuery. In use. Okay, let me try to get in use. Okay, this is a cool one. So 13 permissions are, 13 roles are there, which you get it in BigQuery. We will see the most important one, admin. Let me open that. Then data owner, data editor, data viewer, job user, BigQuery user, then metadata viewer, and there are a few new things which is added. So I'll explore that once we explore these two things, these options. First of all, BigQuery admin, folks. When you look into BigQuery admin, it is going to be comprised of, because it's a predefined role, it's going to be comprised of around 76 permissions. 76 permissions. So where you can create a data set, delete a data set, get the details. Now, if you can create a data set, you can definitely create a table also. You can also create a table. So this is what it has, the superset in your BigQuery. Now, if I go to my owner, it's going to be almost half of the permissions which you are going to have. As a owner, I can create a data set. I can delete a data set. That's all good. But there's one specific permission which you will not be able to have it. What is that? Basically, to run any job. So BigQuery dot create jobs dot create. So every query which you are going to run, right, it's going to be a job to BigQuery. So it's a job. So this job details, to run a job, you should have this permission, BigQuery dot jobs dot create. Please make a note of this very well, folks. This is very important. So this is not to the concept of a database warehouse, but it's something related to the IAM. So you can definitely expect a question, something of this sort. So in an admin can do everything. But if you go to a owner, you don't have that permission itself. Meaning, even if you are a data owner, if you want to run a query, you cannot run it. The same thing applies to a editor who can create a data set, cannot delete a data set, and an editor can also cannot delete or run a job. Same applies to your data viewer, who can preview the data, get the data, do get data. Get data is good. Sorry, not this one. This one. Tables.get. meaning preview of the tables are possible. So if you just give data viewer role, but viewer can also cannot run a job. Now who else can do? Who else can do? A smallest role called as job user can run a job, but this role cannot create a data set, cannot create a table. So it has to be a combination which you have to use. So if you give somebody to work on a BigQuery table and allow them to modify table, all those things, bare minimum you have to give them something like BigQuery data editor role and BigQuery job user role if you were to give them. So bare minimum, that's going to be the one option. Now assume the person is a junior person. He or she needs to learn BigQuery completely, but there's a chance if you give him BigQuery editor role or anything, they may change some data, or out of curiosity it can do something wrong. Now for such people, right, there's a very beautiful role which you get called as BigQuery user. BigQuery user, what does that do? This is equivalent to your Windows profile user. If you have worked in any service based organization, they are going to give you a Windows laptop. You'll have a username, password. When you log in, right, you'll get something like a C users / your name. So you can do only in that, you can do whatever you want inside that profile. You can create folders. Maybe sometimes you can install little softwares which does not require an admin rights, and you can delete those folders, files and all, but you cannot go to C drive and create a folder. It's going to show permission denied. It is the same thing which is going to happen with your BigQuery user role, where you can create a data set. You can create a data set. Once you create the data set, you should be able to create tables, and you can also run a job. So you can query the tables and get the results. So this is going to be a good handy option for people to explore. So instead of giving them data editor role plus job user role, I just give them a role called as BigQuery user role. This is your space. Use it. You create your own data set, delete your data set. I don't care, because that is something which you are going to create, you are going to play, and you can run it. So for learners, if you were to give an access, I would say BigQuery user role is going to be the best fit. Is going to be the best fit. Later, when they are going to have got a maturity to play around with real data, then give them something like at least data editor role and job user role. It's going to be a good choice. It's going to be a good choice. And the last role, which is little important, is metadata viewer. You can give this kind of a role to a people who don't query the table, but only just wanted to see how many rows are there, kind of stuff. Maybe like a manager who does not going to query the stuffs, but they're just going to see how many rows are there. Just they want to keep a or watch how many rows we are exceeding. Are we exceeding it or not? But if with a metadata viewer role, you can only get the table details, meaning the schema and the details of the table. The preview will not be there. To see a preview, you have to have basically a role called as BigQuery tables.get data. So if you don't have this permission, you cannot do this. So where and all you get this permission, basically, if you copy this, for what and all roles you get it is basically, if I put permission filter, I'll put in use BigQuery. So as an editor, data editor, data owner, data viewer, and admin, only you can get preview options. So only 4 roles can do a preview. Remember that. So lots of stuff shared, but I'll put it in a document so that you can refer it back. So all from the exam perspective only. So if I put this one, permission allows to preview the data, preview the native table, which is available in basically BigQuery. I'll do the formatting later, folks. Admin BigQuery data owner data editor and viewer. Now, if you were given a chance, what would be the best role we will give, folks? There are 4 roles which can do a preview. Now, if your manager wants to only see preview details, what would be the best role which you'll give for your manager or a senior people who's not going to run any queries, who just wanted to see the table content, all those things? Preview. What would be the best role, folks? Principle of least privilege. Yes, Mangesh. So this is the preferred one, because others are going to be little more so avoid it basically. So broader access, so try to avoid it. That's it. So, and another important role is, which we were focusing more, was this role. To run this query, you need to have this. So what are the roles which has this? So if I put permission, only 3 roles have this thing. You cannot give admin to everybody. So either you have to give job user role or user role. So this is another important thing. To run any query, to run any query in BigQuery, you need to have permission and permission which is available in BigQuery job user, BigQuery user role. So that's something. Now what I will do is we'll do a small demonstration exploring these things, folks. Exploring these things. So what I'll do is I'll give somebody, admin will never give. Admin will never give. We'll just give data owner to a user and see how this person can access the data. Okay. So I'm going to use Edge browser. I'll go to my IAM, batch 6, add a user, Mahesh, give them BigQuery admin role. Sorry, BigQuery data owner role. Just to understand that a data owner cannot even query. I wanted to show you that demo. That's the whole reason. So give it a data owner role. Done. Now let me log in my Edge browser as this user. So batch 6 is there. Let me just log in. And I have only access to BigQuery. No access to App Engine, Compute Engine, only BigQuery access. So click on that. We have 2 data sets. Remember, we have 2 data sets. So let me explore that. Data set. Click on employees. Now, as a owner, data owner, I can see the schema details. This is the metadata information. I can look into the details possible. I can also look into the preview. Now, if I click on query, folks, click on query, put star itself, it's going to throw me an error. What is that error? User does not have BigQuery.jobs.create permission. So is this part clear, folks? Even though you're a data owner, you will not have permission to basically run a query. You can do a preview. You can do a preview, but not run it. Similarly, if you were to load a new, now you can create a table. Now I can show you how you can create a table. So, or you can create a data set itself as a owner. So create a data set as an owner, data owner. Let me put it in. Yeah, let me leave it as default. I want to expire it in 1 day. As a owner, I have created this. Now, can I create a table? Yes, go ahead and create it. As an owner TB. Empty table, folks. We never created an empty table. Just wanted to show you how to create an empty table. So it's only going to have a schema, all those things. You have to go and basically create the data, all those things. So I'm going to add a couple of fields, name, department. That's it. Now what I'm creating, folks, an empty table. Okay, let me make it very clear. Click on create. I should also be able to create a table. I created an empty table. Now, can I see the details? I can see it. It's going to show this table is empty. Now let me run a query. Now what I'm going to do basically is show you whether I can insert a data. Insert into this table, and the values are name Mahesh, department 2. Now this also shows me the same message. You cannot run any query. So select query or insert query, it shows the same thing. Now you can ask, can I use that option which we learned where we can go ahead and load it from our local system? Give a try. Let's give a try. So I create a table. There's a question. I'll answer it once I finish this. Go upload it from your local machine. So let me go upload it. Give a name as employees. Let the schema be automatically generated. And let me also skip the first row. Now I'm trying to load it. Now if I try to run this, it is again going to throw me an error. You don't have the same permission. So to query, to load the data, you need to have BigQuery.jobs.create permission. Hope this is very clear, folks. Hope this is very clear. So there's one question from Kumar. Can job user do preview or run only the query? Only run query. You'll see that now, Kumar. So he cannot create tables, data sets. But if that role only can run jobs, basically run the jobs. Now, so just data owner is not sufficient, is very, very clear. Now what I'm going to do is I'm going to go back to my IAM, give a additional role. An additional role, what would be the one which you would prefer, folks? He needs to create basically, if I go to my this one. So to have this role permission, you have to either have one of these. You have to have either one of this. So what would be the preferred role which you can give, folks? Preferred role which you can give. No, it has to be this one, because this is having only 3 permissions, folks. This has only 3 permissions. So if you go here, job user has only 3 permissions, principle of least privilege. But if I give BigQuery user role, 24 permissions are there. Already I have gave him owner role. Why do I need to give more further roles? So I don't want to complicate things. I'm just going to give basically BigQuery job user role. That's going to be always the preferred one if somebody needs to run any query. So this is going to be the preferred one because it is having only 3 permissions. Less permission, principle of least privilege, because it contains only 3 permissions. So now let's give that role and see what is going to happen. Done. Now let me go and try whether I can run it. Now this command, right? Let me run it once. It thought it was not having this error, having issues. Let me see this, whether it's going to work now. Awesome. I was able to add a row. Now if I go back, look into the preview, I see Mahesh. Can I query this name? Can I query this? Yes, I can query it because I am now the owner plus job user. So hope this part is clear, folks. So it's always important you give both the
Then Mahesh, why we need to give owner and job user? Then why can't we directly give admin? Then he can have both, right?
No. Admin has more other privileges. So if you now look into it, so it's not only this. Now admin can do some reservations. So there are something called as slots, which you can do reservations. So you can do that commitments, all those things. So it's going to have more. So owner is just 35 permissions. So along with this, you need one more permission. Just BigQuery jobs.create. That should be good enough.
Got it.
Yeah. So now what we will do is I'm going to leave like this. Now because I'm the owner, right? I can also delete data sets. So I'll just delete this data set itself. I'm not deleting the data set which I created, folks, for a reason. Now I deleted it. So I can delete because I'm the owner. I can do everything, but I cannot query if I don't have the role. Now what I will do is go back and make this user. I will remove both of this. This is one combination which you can give. Now, if you don't want him to delete data set, better give him data editor, so that as an editor, you can only create, but you cannot delete it. So that way you can do it. But if it's a junior person whom you want to give some access for him to learn or her to learn, basically what I would suggest is remove all these things, give a role which is going to be called as BigQuery I'm a great fan of this role, BigQuery user. It gives you every stuff within your own space. You are an admin within your space, within your own space. So something like you are the king of your own house. So something of that sort. Whatever you want, you can do that within your house. So that's the same concept works here. Now what I will do is I'll switch back, refresh the screen. I'm just going to refresh a couple of times. I have logged in back as Mahesh. Now click on dataset. Click on the dataset. Now when I open it, I see 2 data sets. Now let me explore this data set, folks. Employees. Now I see the details. Preview. Not sure whether it is reflecting. It's not reflecting actually. 1 minute. The preview should not show actually. Whether it's reflecting. 1 minute. Let me just sign out. Other data set, you should not be able to see it. You can see your own data set. do everything, but other data set you should not be. Just trying to refresh it and see. Yeah, this is what I wanted to see. So now if I click on batch 6 data set, employees, it shows me like this. You don't have details to look into this specific data set, tables.get. Now you may ask, if you just copy this, let me just copy this permission, go to my user, table, I don't get it. It's not there because the permission is not there. You may say it is not there, but it's not that way. The reason why he's not able to see this data set is, as a BigQuery user role, you can create your own. You can create your own data set. You can see the tables inside it. But any other data set in that project, you will not have access. You will not have access. Any table you see, it's going to show the same message. Any partition table also is going to share the same thing. If I go to this data set, I will be able to see it. I'll be able to see it. Is there anything which is wrong here, folks? This data set, I cannot see it, but this data set, I can see it. Any reasons why? Any reason why? I can create a new data set. I can create a new data set as a BigQuery user. One day expire. This is fine. This data set, I only created it. I can create a table, demo, auto detect. Let me see whether I can create a table. So now table is created. This is my own table. I created it. I can see it. I can preview it. I can also query it. I can also query it. This is all accepted. This is all accepted because I created it. I can see it. But why I'm able to see this as a owner thing is because, as Anil B mentioned, you created it. You only created it when you were a data owner. So it is still the same user, right? So you were the same user at that time you created it. That's the reason you have it. Now, how can I see that? How can I see that? Basically, if I go back to my owner screen, go to my BigQuery, look into my as a owner data set, look into my permissions, folks. If I look into the permissions of this, you will see who created this. You see this? Mahesh created this. That is the reason he's able to see it. Now, if I look into my batch 6 data set, look into this permissions, look into the permissions. This is giving at a specific data set. Now, if I look into this, there's no Mahesh. That's the reason I cannot see it. I cannot see it. So if I go here, this was created by Mahesh. So looking at the permissions is definitely going to show Mahesh is as one of the BigQuery data owner only for this data set. Hope this is clear, folks, why he's able to see it. Now, if you go to your as a data owner, click on the permission, revoke the access for Mahesh, revoke it, remove him, done. Now Mahesh will be able to only see as a BigQuery user, which he created. So let me just show you that by just doing a refresh. So better maybe log off and log in. I should not be able to see it. It's not reflecting once. 1 minute. I'll just query it once, folks. I'll just query it once. Okay, now it is reflecting. You see this? Does not have the permission to query the table. So hope this concept is clear. So who goes and creates it will be basically the owner of that data set, and they own that. If you downgrade them, make sure you revoke that access. Otherwise, they can still continue doing it. There are mistakes people do like this. They gave them higher privilege. He would have created data sets, all those things. Now they understood that he's doing something wrong. You downgrade him, but make sure what are all the data sets he created, you remove his access. Otherwise, he is going to continue having the access. Hope this is clear, folks. Hope this is clear. Let me just stop it here. People who have a hard stop can log off. People who have questions, I'm happy to answer your questions. So we'll stop it here. Next week when we resume back, we'll talk more about data viewer access, all those things, where you can see the preview options, all those things. So just wanted to highlight now the owner, job user role, and user role, the importance of those things. Data viewer role, we'll see it next class. Let me just stop it here, folks. Any questions? Happy to answer. Any questions, folks?
Mahesh, again, going back to my original question earlier, when we are doing the partitioning expiry, we can do with the day, year, month, and everything, right? That's what you said.
Yeah.
Is there any way we can do with like 7 years, 5 years as well? I mean, I want to see in the UI. Is there any way
In the
we
UI,
can?
it is not there. In the UI, okay. So you want to expire by 7 years, right?
Yeah, exactly. Yeah.
Okay. What you do basically is, so when you mention expiry by 7 years, maybe I can give a try. There's no harm. So why don't I do that? So you put 7 years basically. That's it. So if I open, there's no option to do that partition expiry by UI, Kumar. So you have to do it in command line only. So there's no
Okay.
UI option. So you have to do it in command line. I'll just create one table which is going to expire by 7 years. Let me just show you that. So I'm just going to use the same command which I have. This one. So I'm going to make, instead of day, right, I'm going to make it as year. That's the first thing. Now you wanted it as 7 years. So I'm just going to mention it as 7.
Okay. Got it.
7. Let's give a try. Batch 6 underscore DS partition expire table Kumar. Okay. So that's the one. Let me try creating it. Done. It is created. Now if I do BQ ls batch 6 underscore ls, sorry, batch 6 ds, you see it is by 7 years. That's it. It is
Thank
by
you.
year. That's it.
Yeah.
Any other questions, folks? Okay, no questions. Fine, folks. There's no questions. We'll stop it for the day. So resume back on next Saturday. All right, folks. Thank you.